Hi KCET 2025 aspirants. So we are just left with few days for our exam, right? And at this point of time, it is very important to do rigorous practice of questions. So in this video, I have brought you 100 questions from all the chapters. I have given more questions from high weightage topics, little bit from previous year questions, little bit from the questions that we can expect. So the entire syllabus is covered with this 100 questions, and by doing this videos you can easily get 35 plus. Okay, you can get 40 plus also, but I'm telling the bare minimum that you can score. Okay, so please watch this complete video and solve all the questions with me so that you can secure a very good mark for yourself. Okay, now let's get with the first question, that is solutions. Okay, from the solutions, first let me tell you what all things you need to focus on this chapter. So the first thing that you should be very important is your colligative properties. Okay, so please revise colligative properties properly. Okay, you have to get at least revise all the formulas from colligative properties. Next, you have to do the examples for ideal and non-ideal solutions, positive and negative deviation, maximum and minimum boiling azeotrope. So just take out your NCERT book and remember all the examples for all of them. Next, what I have? Next, I have questions from Van 't Hoff factors. Okay, some question from Van 't Hoff factor will also be there. Colligative properties, all the four formulas, and then you have Henry's law. Okay, so these are the important questions and we are covering questions from these topics. So let's get started with the first question. Which one of the following equilibrium exists in a saturated solution of solid in liquid? So when you dissolve a solid in a liquid, right, now it is a solution. So there the equilibrium is between your solid and that is your solute and solution. Okay, there's an equilibrium between the solute and the solution. So my correct answer will be option number C here. Next, which one of the following aqueous solution has the highest freezing point? This is a very important question and many students do mistake in this question. You have to find out the highest freezing point. Okay, now always remember, in freezing point when you add a solute there is a depression, right? So more the depression, lesser will be the freezing point, right? And if we have less depression, we will have higher freezing point. Okay, now you see molality is same in all of them. So the only thing that is affecting here is the I value. So now let us see, suppose the freezing point is 0 degrees Celsius for water I am considering. Okay, now you added option number A. What is the I value? 5. That means the with I value 5, what will happen? The freezing point will depress 5 times. Let us imagine it will depress by 5 times. So I got somewhere here is option number A. The freezing point now here is this one. Now here I have I value is equal to Ba 1 ion and chlorine is 2 ion. So I will get I equal to 3. So it will depress somewhere less than this one. Okay, so this is the freezing point with barium chloride. Next, aluminium chloride, I have 4, I value equal to 4. Why? Because 1 aluminium and 3 chlorine. So it will be somewhere here. Okay, it is option number 3. This will be the freezing point. Okay, next I have NH4Cl, I value will be 2. So here the depression will be minimum. That is option number D. Now you see where the freezing point will be least. The freezing point will be least in option number A, then it will be in option number C, then will be in B, and the D will be at the end. Means the highest freezing point will be option number D. So if you see, I will just write down this is -1, suppose -2, -3 and -4. So -4 will be A, then you have this one C will be -3, then D will be -2 and A will have the highest freezing point. Okay, so please remember, if depression is minimum, highest freezing point will come. If the question would have been asked lowest freezing point, then it would be option number A. Okay, so that is why here answer will be option number D. Next, we have the mole fraction of water in which the CO2 is dissolved is 0.97 if its partial pressure is 2 bar. The Henry's constant is. So we have the very simple question, the mole fraction of the water in which the CO2 in dissolved is 0.97. So we know that mole fraction of water given to me is 0.97. That means mole fraction of the solute will be how much? 1 minus 0.97, so that will be 0.03. Next I have partial pressure is 2 bar. Okay, partial pressure is 2 bar, and then the Henry's constant you have to find out. Okay, partial pressure is 2 bar and you have to calculate the Henry's law constant. So I have this formula, P of the gas is equal to, so whatever formula I am writing, please note down that formulas. Okay, kH into mole fraction of the gas. Now what is P of the gas? That is 2 bar. Okay, kH of the gas I have to find out, and I have mole fraction is 0.03. Right, next I can write down 2 by 0.03 is equal to kH, or I can write down as 200 divided by 3. Okay, so this one will give me 66.66. It will continue. So option number B here, direct formula based question. So what formula we have to remember? Henry's law formula. Okay, next question number 4. Mass of the non-volatile solute with molecular mass 60, which is dissolved in 100 gram of heptane to decrease the vapor pressure to 90%. Okay, so this question is from your relative lowering vapor pressure. The question is asking here how much amount. So whenever I add a solute to a solution or to a solvent, okay, whenever you add a solute to the solvent, the vapor pressure will decrease. Okay. Now according to this question, what is there? How much non-volatile solute you add to the solute molar mass is 60 to 100 gram of the heptane. So the solvent is heptane. So how much mass of non-volatile solute will be added to heptane so that the vapor pressure, so that to decrease the vapor pressure to 90%. If earlier it was 100%, now the vapor pressure becomes 90%. Okay. So let us do this question. We have direct formula. What is our formula? Delta P by P naught is equal to XB, or it can be written as NB by NA. Okay. Now what is delta P? It is P minus P naught minus P by P naught, right? So it is 100. Next, pressure to 90%. Earlier it was 100%. Now the final pressure is 90%. So P value will be 90 divided by 100. Into, you have to calculate the number of moles of B. So number of moles of B will be what? Given mass of B divided by molar mass of B, that is 60, WB by MB, into what will be the molar mass of the, here it is 100, right? And the heptane mass is what? Heptane mass is C7H16, right? So I can say 12 into 7 plus 16, so 7 2s are 14, 7 1s are 7 plus 1, 84, 84 plus 16 will be 100, right? So I got number of moles, here it is 1, very easy calculation I can do. So I will get 10 by 100 equal to WB by 60. This I will cancel. What is the mass required? 6 grams. Okay, so I have option number D here. 6 gram will be the mass, or that means if I add 6 gram of this non-volatile solute to 100 gram of heptane, the vapor pressure will decrease by 90%. Okay, will decrease to 90%. Okay. Next, an aqueous solution contains 6% and 4% by mass of X and Y respectively. The boiling point of the solution is. Now generally in our NCERT book, whatever questions we have regarding the boiling point, it is in the form where we have delta TB is equal to KB into M, and this M is generally for one solute. Okay, when you have been given with 2 solutes, you have to add the total number of moles and then you have to calculate the molality. Okay, now for example, let us do, we have what, an aqueous solution contains 6% of X. Okay, 6% and 4% by mass of X and Y. So X is how much? 6%, and its molar mass is how much? 120 gram per mole. Molar mass is 120 gram per mole. So what is the number of moles of X? That is 6 by 120. So that is 1 by 20. Okay, or I can say 0.05. Okay, now similarly if I have Y, okay, so that is 4%, Y is 4%, and I have molar mass of Y is 180, and number of moles of Y will be 4 by 180. So 2 2s are 4, 2 9s are 90. Then I can write 1 by 45. Okay, and if I want to just calculate what is 1 by 45 here, up to you can calculate 45 2s is 90, right? 10 again 0.22. So I can write 0.022. Okay, now what is the total number of moles? Total number of moles is number of moles of X plus number of moles of Y. Okay, so that is 0.05 plus 0.02, so I will get 0.072. This is the total number of moles. Now what is the molality here? What is the formula for molality? Because I have Kb into m, right? Molality is what? Number of moles, right? Number of moles into 1000 by mass of the solvent, right? Mass of solvent in grams. This is the formula for number of or for molality. Number of moles I got 0.072 into 1000. Now what is the mass of the solvent? Now see, in a solution, okay, in a solution you have 6 gram, total mass of the solution is 100. Percentage is given, that means total mass of the solution is 100. In that 6 gram is X and 4 gram is Y, right? 6 gram is X and 4 gram is Y. That means 10 grams total is solute. So what is the mass of the solvent? 100 minus 10, that is 90. Okay, now I can just multiply this 1000 here. So I will get 72 by 90. Okay, so 9 8s are, I will get 0.8. So what's the molality I am getting? 0.8. Now let us solve this part. Delta Tb. Okay, so I am just erasing this one. So I already calculated molality. So this molality calculation is clear. Once again, see, when you have two types of solute, you are adding two different solutes. First calculate the number of moles of each of them, then add the total number of moles, and then calculate the molality. You will get I think I have done the correct calculation. Yes, so we will get 0.08 as the molality. Next I will do the next part, that is normal. I have got the molality. I will just proceed according to the formula. So Tb, the boiling point, you have to calculate the boiling point of the solution. So that is your Tb, right? And you can see the options are in given. I'll just write down at T naught B, that is 373. Okay, I am doing it in Kelvin because I have here it is in Kelvin. Okay, equal to Kb value is 0.52 into molality is how much? 0.8. So let me just multiply. 8 2s are 16, 8 5s are 40 plus 1 41. Okay, and this one will give me how much? 3 decimal place, 0.416. So what is Tb value? 373.416. Okay, this is in Kelvin. Now if I want to calculate Tb in degrees Celsius, I just have to subtract 100 minus, from here I have to subtract 273. So 373.416 minus 273, that will give me 100.416. Okay, so that is option number A here. So now the basic you understood, that earlier the boiling point of water is 100 degrees Celsius. Now if I add in that 6 gram of X and 4 gram of Y, the boiling point will increase, right? And what will be the new boiling point of water? 100.416. Now by seeing the options, we itself can eliminate first option number B. Why? Because it is decrease in boiling point. So always the boiling point will increase on addition of a solute. So here option number A is the correct answer. Next, 3% W by V aqueous solution of glucose is isotonic with 2% W by V aqueous solution of X solute. Okay, if 6 gram of X is dissolved in 100 gram of water, the molality of the solution is. Okay, so first let us see here. When it is isotonic, that means the osmotic pressure is same. That means I have pi 1 is equal to pi 2. Okay, osmotic pressure of the aqueous solution of glucose. So osmotic pressure of glucose is equal to the osmotic pressure of X. Now osmotic pressure of glucose will be what? C1 R into T, and that will be equal to C2 into R into T. Now what is C1? 3% of glucose, right? That means 3 gram given mass by molar mass of glucose is 180, and here it will be C2, that is 2 divided by molar mass of this one. Now how can I solve this molar mass? Molar mass will be equal to 2 into 180 divided by 3. Okay, so that will give me 120 grams per mole. Okay, so I got the molar mass of X as 120 gram per mole. Now what you have to calculate, that if 6 gram of X is dissolved in 100 gram of water, the molality of the solution. So I can calculate what is the number of moles of X given mass by molar mass. Now for the second part, 6 gram I dissolved by 120 grams. Okay, or let me directly put the formula of molality. We can do it in one step. Molality is equal to what? Given mass of the solute by molar mass of the solute into 1000 by mass of the solvent. So I have here 60 grams, sorry 6 grams, not 60, 6 gram divided by 120 into 1000 by 100. Okay, 100 gram of water is taken, right? So you can just cancel this one, 1 by 2, that is 0.5. So I will get 0.5 molal, option number C here. Okay. Next, in a 0.2 molal aqueous solution of a weak acid HX, the degree of ionization is 0.3. Taking Kf for water as 1.85, the freezing point of the solution will be nearest to. Okay, so here we have something related to Van't Hoff factor. So you can see that the degree of ionization is given. Okay, and degree of ionization is given, that means from there I can calculate the Van't Hoff factor. So for dissociation, ionization you can compare it with dissociation, right? So for dissociation, what is the formula of alpha? That is equal to I minus 1 by n minus 1. Now if I want to calculate the value, what is alpha value here? Degree of ionization is 0.3, I minus 1. What is n value? N value means how many ions it will dissociate. Hx will give you H plus and X minus, 2 ions. So 2 minus 1. So that will be equal to, I will be equal to 1.3. Okay, that's the first thing. Next, taking Kf for water as 1.85, the freezing point of the solution. So now what I will have, delta Tf is equal to I into Kf into m, right? I value I got 1.3, Kf value is 1.85, okay, and molality is given to me as 0.2. So let me just calculate this one first. So 185 into 13, 3 5s are 15, 3 8s are 24 plus 125, 3 1s are 3, 4 5, then I have 185, I'll get 5, 10, 8 plus 1, 9 plus 14, 1, 2, 4, 0, 5, and I have 3 decimal places, so 2.405. okay, so these calculations you can do in the exam. Okay, 2.405 I will get into 0.2, so that is 2 5s are 10, 2 zeros are 1, 2 4s are, okay, just a minute. Okay, so 2 5s are 10, 2 zeros are 1, 2 4s are 8, 2 2s are 4, right? Again I have 4 decimal places, so 0.4810. Now delta Tf is what? Tf means T naught F minus Tf, okay, so that is 0 minus 0.4810, that will be equal to Tf of the solution, so minus 0.48. okay, so option number A here. And I want to add one formula here also, alpha for association. What is the formula? I minus 1 divided by 1 by n minus 1. So please remember these two formula, it can be asked in the exam. Okay. Next we have one question, which of the following aqueous solutions has the highest freezing point? So just now I think already discussed this question, that will be option number D. Okay. So next chapter we will move electrochemistry. So let's start with electrochemistry. So students, now after completing solutions chapter, let's move to the next chapter, that is electrochemistry. See the first question here, consider the following electrodes, the reduction potential in the order. Okay, so you have to tell the reduction potential. So now if we know the Nernst equation formula for your single electrode, okay. So what is the Nernst equation for single electrode? I have E of the cell equal to E naught minus 0.059 log of 1 by, okay, 1 by what is the concentration of silver? Ag plus, right? So this is the concentration of Ag plus. Now for different values we have been given with Ag plus concentration. So now I can also be given with E naught value. So that is 0.8 minus 0.059, n is 1 here, so I have not taken, log of, so you can see 1 by Ag plus concentration is 10 to the power of minus 4, right? So this becomes 10 to the power of minus 4, it goes up, and we will get 0.08 minus 0.059 into 4, right? This goes up, plus 4 log 10 is 1, so I will get 0.059 into 4. I hope this is clear. So log of, see, I can write log of 10 to the power of 4, this one, and that is 4 log 10. Log of anything to the power of x will become x log 10, and log 10 value is 1, so this value became 4. I hope this is clear. Now you don't have to solve this, okay, you don't have to solve this. Now just imagine, now based on this, okay, what I am getting, 0.059 into the power of 10, right? That is what. Now the second option, if I go, what I will get, 0.08 minus 0.059 log of 1 by, what is this, 10 to the power of minus 1, that goes up, right, plus here, and I will get 0.8 minus 0.059. Next, see, if I take, it is 10 to the power of minus 2, right? So 0.8 minus 0.059 log of 1 by 10 to the power of minus 2, okay, that goes up, so I will get here 0.8 minus 0.059 into 2. Now for option number D, I will have 0.8 minus 0.059 into, what is the term here, 3 times I have multiplied, so into 3. Okay, so now what all things I have, you can see, this is first option number A, this is B, this is C, and this is D. So you see that if you are subtracting a bigger number, then E naught value will be less. If I am subtracting a smaller number, this is into 1, right? Now you can see in option number D, you are subtracting a bigger number from 0.8. So that means this E value will be the least one. So the least value will be for your solution, this is A, right? The A one will be having the least electrode potential. So I have only one option where A is least. So I can say that the answer will be option number A. But let's check the other options. Now the highest one will be where I am subtracting the least number. You can see this is the least number, 0.059 into 1. So we are only subtracting 0.059 from here. So this one will be the highest. So B will be highest. Okay. After that, we will be having this one, 3 will be the second, towards the end it will come at the second, and after that this one. So in this way you can understand that in case of if you what I am doing here, if I am taking up electrode, if I am taking the electrode potential, and if you are decreasing the concentration, here you can see you have decreased the concentration, here you are decreasing the concentration. So when you keep on decreasing the concentration, the E naught values decrease, right? You can see here I am having minus 10 to the minus 4, least concentration, E naught value is also least. Okay, so option number A will be the correct answer. Let us solve the next question here. So it is a Nernst equation question. You have been given with E naught value, E value, concentrations are given, and you have to calculate the pH of the solution. Okay, so let's do this calculation. It is a little bit, I can say, lengthy question, but do not worry, we'll do it. Okay, so I have E of the cell equal to E naught of the cell, right, minus 0.059. I will take it as 0.06 because you can see that number of electrons is 6 here, log of, what is the ions concentration, chromium, and in this side I have H plus and Cr2O7. So I have chromium 3 plus concentration square divided by Cr2O7 2 minus into H plus to the power of 14. Okay, so this is my equation. Okay, now let's substitute. What is E value? 1.067. What is E naught value? 1.33 minus 0.01 log of Cr3 plus, that is 15 15, okay, and here I have Cr2O7 4.5 into this one I can write plus H plus to the power of minus 14, okay, that is there. Next what I can do, I can cancel here, 15 ones are 15.3s are, right, then 3.135, now this goes up, so 50, so I will have 1.067 or 1.33 minus 0.01 log of 50 into H plus to the power of minus 14. Okay, this is there with me. Now let me solve this part and let me just keep log on one side so that I will have easier in solving. So first let me divide this one, subtract 1.33 minus 1.067, right? So 10 minus 7 is 3, 12 minus 6 is, then I will have 3, 7 plus 3, 10, 6, 13, okay, sorry, 1 second, okay. So I have 10 minus 7, 3, 12 minus 6, 6, here I will get 0.263, okay. So that is minus 0.263 divided by minus 0.01, okay, you just divided this one, is equal to log of 50 plus log of H plus to the power of minus 14. Okay, log A into B is log A plus log B. Now this one will be equal to what? 26.3, I can write like this, see, 263 divided by 1000, and this side I have 1 by 100. So I will get 26.3. Okay. Now this one is equal to what is log 50 value? Log 50, if you see, that is log 5 into 10. Log 50 I can write like 5 into 10. Now log 5 value is 0.698. Log 10 is 1, so 1.698 I will get. Okay. So I can write it as 1.698 minus 14 log of H plus. Okay. Now you have this one 26.3 minus 1.698. So what I can do, I will just subtract this one. Okay. So now we have here 26.3 and 1.698. Okay, just subtract it. Okay, so I can see 24.602. Okay, I will get 24.602. Okay, then divided by 14 is equal to minus log of H plus. Okay, so minus log of H plus is nothing but pH. Okay, now 24.602, you have to just divide this one. So let me divide. So you can see that it will be 14 2s is 28, right? 24.602 divided by 14, right? So 14 1s is 14, 10, 106, then I have 14 7s are 7 4s are 12, 7 1s are 7 plus 1, sorry, I can have 14 8, 8 4s are 32, 11. So yeah, I cannot have 8, so I have to take 7. 7 4s are 28, 2, 7 1s are 7, 8 9, 98. So 16 minus 8, 8. So I'll get 8 and 0. Then I can take 14 6 are 84. So I can take 14 5, 1.75 I will get. So pH is equal to 1.75 and you have to say nearly equal. So 1.75 we can round it off to 2, that is option number A here. Okay, so this one is definitely a lengthy calculation based question, but yes, in chemistry you will get certain lengthy questions for calculation because there are certain questions where you can do it in short time. Next, moving to question number 10 here. Okay, given the value of E naught is given, this value is given, the equilibrium constant of the reaction taking place in galvanic cell consisting of 2.303 RT above 2 electrodes is how much? So you have to calculate the equilibrium constant. We know this formula, E naught of the cell equal to 0.059 by N log of K. Right now you can see that for the given this one, we have Fe3 plus reduction potential of Fe is 0.76 and reduction potential of I2 is 0.55. So definitely this one is having higher reduction potential. So this will be the cathode, this will be the anode. So what is E naught of my cell? E naught of the cell will be E naught of cathode minus E naught of anode. And what is cathode here? The one which is having higher reduction potential. So E naught of Fe plus 3 to Fe plus 2 minus E naught of what is anode? I2 to I minus. Right? So I can have 0.76 minus 0.55. Okay, 6 minus 5, 1, 7.21 I will get. So what is E naught of the cell? 0.21. It is 0.21 equal to this one they have told to calculate as 0.06, right? 0.06. What is the n value here? You can see that Fe plus 3 to Fe plus 2 will require 1 electron, but I2 to I minus will require 2 electrons. So I can say that if I can just take, I can write the reaction. If I want to write the reaction, it will be like this. See, Fe plus 3 to, that is undergoing, so I can write like this, is equal to Fe2 plus, and I2 is getting converted, sorry, 2I minus, okay, gets converted to I2 by release of 2 electrons. Now this one I can multiply with 2, the whole equation. So what I will get here? So the number of electrons you can see involved is 2 here. So n factor will be 2. So I can write the n factor as 2 here. Okay, 2 log of k. So I have to find this k value. So you can see this is, I can write 0.03 and this one will be 7, 3 7s are 21 log k. So what is k value then? 10 to the power of 7. That is option number D here. Okay, direct easy question. Next one. A 1 liter solution of MgCl2 is electrolyzed completely by passing current of 1 ampere for 16 minutes and 5 seconds. The original concentration of MgCl2 solution was. So here you can see that this is Faraday's law. Original concentration of MgCl2, we just have to find out the number of moles of MgCl2 that was present. Okay. So now if you know that Faraday's law tells you that M is equal to molar mass divided by N into 96500 into I into T, that is Faraday's law. Now here we have to find the number of moles. The concentration is asked, right? It is, the volume is already 1 liter. So if I just can find out the number of moles of MgCl2 present that was got deposited, so I can tell you the concentration that was earlier present. So how can I get number of moles? This M divided by capital M if I write. So it is like this. Small m, that is molar mass divided by molar mass, is equal to 1 by N into 96500 into I into T. Okay. So what is this one? Number of moles. 1 by, what is the value of N here? N is the number of electrons that is used. So Mg, how will it deposit? Mg2 plus 2 electrons gives me Mg. Right. So we have here 2 into 96500 into, what is I? I is 1 ampere. Time you can see 16 minutes and 5 seconds. So 16 6 are 96, right? 16 into 60. So 960 plus 5, 965. So I have 965. So I can have this one as 10 to the power of minus 2 and 0.5 into 10 to the power of minus 2. So I can write it as 5 into 10 to the power of minus 3. So what is the number of moles in 1 liter of the solution? 5 into 10 to the power of minus 3. So concentration will be option number A here. Okay. Next, same amount of electric current is passed through the solutions of AgNO3 and HCl. If 1.08 gram of silver is obtained in the first case, the amount of hydrogen liberated at STP in the second case. Okay. So this is also a question from Faraday's law. Now see, you are giving same amount of current to silver and to your HCl solution. In HCl what will happen? H plus will move towards the cathode, hydrogen gas will be liberated, and in the AgCl, AgNO3 what will happen? Ag will move towards the cathode and Ag will get deposited. So we have already given with how many mass, what will be the mass of silver that will be deposited. So by using Faraday's law, can we calculate what will be the mass of hydrogen gas produced, and once we got the mass of hydrogen gas produced, we can convert it into volume, right? That is the basic formula. So I can say that mass of hydrogen produced divided by mass of silver produced will be equal to the equivalent weight of hydrogen divided by the equivalent weight of silver. Right. Now what is the formula for equivalent weight? Equivalent weight is equal to molar mass divided by n factor. Right. Now for H2, what happens? If you see H2, 2H plus 2 electrons gives you H2. Right. What is the molar mass of H2? It is 2 grams. N factor, how many electrons? 1. So equivalent of weight of H2 is 1. Next, equivalent weight of silver. Equivalent weight of silver. What will be that? You know what is the molar mass of silver? How does silver got deposited? Ag plus 1 electron is equal to Ag, right? So what is the mass of silver deposited? Silver deposited is 108. Okay, molar mass of silver is 108. N factor is 1. So equivalent weight will be 108. So now I can have mass of H2, okay, divided by mass of silver deposited. How much? 1.08. is equal to equivalent weight of hydrogen is 1, equivalent weight of silver is 108. Now from here, can I calculate mass of hydrogen? So that will be equal to 1.08 by 108, and which is equal to 10 to the power of minus 2. Right. So mass of silver deposited was 10 to the power of minus 2. Then can I calculate number of moles of hydrogen deposited? Number of moles will be what? You know this formula, number of moles is equal to given mass by molar mass. Okay. Now if I already have got the mass of silver deposited, I just want to, okay, 1 second. Yes, what's the number of moles? Given mass by molar mass. So my given mass or mass of hydrogen is 10 to the power of minus 2. I can divide it by the molar mass of H2 to get the number of moles. So it will be 1.2 into 10 to the power of minus 2, or 10 to the power of minus 2 divided by 2. That is what? Number of moles of hydrogen gas. Next, volume of hydrogen gas. At STP, 1 mole occupies 22,400, and I have this many moles. So how much it will occupy? 1 by 2 into 10 to the power of minus 2 into 22,400. Okay. So I will get 112. So that is your option number C. Okay, simple thing. Up to this, I think everyone should be able to know. After that, you have to just convert it into mass and then convert it into volume. Okay. Next is question number 13 here. So the pair of electrolytes that possess the same value of D by Huckel-Onsager equation, same value of A. In this equation, this A is a constant, and if the two electrolytes have same positive charge and same negative charge, then they will have the same A value. For example, if you see here, NH4 plus is there, Cl minus is there, Na plus is there, Br minus is there. Cation charges are same, anion charges are same, right? So that is why A value will be same for both of them. Option number A here. Next, by passing electric current, NaClO3 is converted to NaClO4 according to the following equation. NaClO3 plus H2O gets NaClO4 plus H2. How many moles of NaClO4 will be formed when 3 Faradays of charge is passed through NaClO3? Okay, so let us first understand the conversion of NaClO3 to NaClO4. Okay, what is the charge of chlorine here? Plus 1 plus x minus 6, it is plus 5, right? And here it is x 8, so it is plus 7. Okay, so plus 5 to plus 7 is there. The conversion has plus 5 to plus 7 oxidation. So that means how much Faraday or 2 moles of electrons is lost. So I can say that 2 Faraday, okay, will give you, so if I pass 2 Faraday of current through NaClO3, I will get NaClO4, 1 moles of NaCl4. So 2 Faraday will give me 1 mole of NaClO4. If I give 1 Faraday, it will be 1 by 2 mole of NaClO4. And in the question they are giving me 3 Faradays, so 3 by 2 moles of NaClO4, right? So if I pass 3 by 2, that means 0.1.5, that is option number C here. Next, in H2O2 fuel cell, the reaction occurring at cathode. So at cathode what happens, your H2 is in this you can remember this reaction, you can see for anode and cathode I have noted down. Okay, so please remember, in oxygen hydrogen fuel cell, oxygen is at the cathode and anode we have hydrogen. So oxygen undergoes H2O plus 4 electron gives you 4 OH minus, that is option number A here. Okay, next next we will move to chemical kinetics. Okay, let's do some question from kinetics. So you have a hypothetical reaction given below. Order of the reaction by RDS method is. So always remember, the order of the reaction is given by the slowest step in the reaction. Now here the slowest step is this one. So I can write that R is equal to K into A into B2. Right? Is it complete? Yes, I have written the rate law according to the slowest step. But now if you see properly, in my reaction, I have A2 plus B2 gives me 2AB. In my entire reaction, what is rate law? Rate law is the expression where you tell about the rate in terms of the concentration of the reactants. Now in this entire reaction, I don't have A as a reactant, right? A is not present at all as a reactant. So I cannot write A directly, right? Because A is not there in the final equation. So I have to represent A in a different form. So for that you can see this equilibrium reaction is there. I can write this one as K equilibrium will be equal to what? A square divided by A2. Okay. Now I can multiply, this is, I can write A2 into K equilibrium is equal to A square. Okay, A square. And I have taken the root over of this one. Okay, so I can write A2 half and K equilibrium half is equal to A, right? That is the actual value of A in terms of A2. Now I can substitute that here. So what will be rate now? K into K equilibrium to the power of 1 by 2. Then A is equal to A2 1 by 2 and I have B2. Okay, so now this is both are equilibrium constants or rate constant and equilibrium constant. I am mentioning them together as K dash. Then I have A2 1 by 2 and B2 1. So 1 plus 1 by 2 is 3 by 2. So what is the overall order here? 3 by 2. Okay. Next, I have a question. A gives me P plus Q plus R, follows first order kinetics with a half-life of 69.3 seconds at 500 degrees Celsius. So what is my T half? T half is 69.3 seconds. Okay. Starting from gas A enclosed in a container at 500 degrees Celsius and at a pressure of 0.4 atm, the total pressure of the system after 230 seconds will be. Okay, so we have to calculate after 230 seconds what will be the total pressure. So let us do this one. You have this, right? A gives me P plus Q plus R. What is the pressure of A? Pressure of A is 0.4 atm initially. Okay. Then I have 0.4 minus x after some time. So it is, what is the time given? After 230 seconds. So t equal to 0 and t equal to 230 seconds. Okay. So 0.4 minus x, then x and then x. So what is the total pressure? Total pressure will be 0.4 plus 2x. Okay. So now my task is to find this value of x. If I can find that, then I'll get the value of total pressure. Okay, let's do what next. What I can do, what is the value of K for this reaction? K will be equal to 0.693 by T half, that is 69.3, right? So what is this number will give me? 693 by 3 zeros, that is 1000, and then I have 693 divided by 10. Okay, so it will be 10 to the power of minus 2. So K value is 10 to the power of minus 2. That also I got. Now let us calculate. K equal to 2.303 by T log of P naught by P. Okay, initial pressure of A by final pressure of A. Okay, K value I got 10 to the power of minus 2. This is 2 point, let me just write it at 2.30 so that we can cancel. 230 seconds is there, so this we can cancel. Log of P naught value is 0.4 by P. Okay, now what I can do, this is also 10 to the power of, so I can just write down 2.3, 1 second, this I can write like this, 2.3, or I can write 23 by 10 into 230, right, 23 by 10 by 230, 23 by 10 and then 230, right. So I will get 10 to the power of 2 again, this one will also be 10 to the power of minus 2. So I have 10 to the power of minus 2 equal to 10 to the power of minus 2, just a minute, yes, log of 0.4 by P. Okay, this one will get cancelled. Okay, so I can have, now let me just erase from this part. Okay, okay, just a minute. Okay, so now I got that log of 0.4 by P, that gave me how much? That gave me a value of, you can see, 1 is equal to log of 0.4 by P. Okay, now if I take anti-log on both sides, then if I take anti-log on both sides, that will be 10 to the power of 1 will be 0.4 by P, or P will be equal to I can say 0.04. Okay, now if you remember, in this we have started with A gives me B plus C plus, sorry, A was giving me P plus Q plus R, right. So I got A was giving me P plus Q plus R, and I started with 0.4 and 0.4. After 230 it was 0.4 minus X, right. So what is this? Total pressure, that is 0.4 minus X is equal to 0.04, right. So the pressure of A after 230 seconds is 0.04, and that value was nothing but 0.04 minus X. So now I can say that, I can do this calculation here. So I can say that, see here, I can say that 0.4 minus X is equal to 0.04. So what is X value then? X value will be 0.4 minus 0.04. Okay, so I have 0.4 minus 0.04, 0.36 I will get. Okay, so this is the pressure, this is the value of X. Now if you remember, we got X, 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 so I added, so the total pressure we calculated was 0.4 plus 2X, right. So I can just substitute that and calculate the total pressure. So we can calculate here, P total is equal to 0.4 plus 2 into 0.36. Okay, so 0.4 plus 2 6 are 12, 2 3 are 6 plus 1 7, 0.7. So I will get 1.12, right. 7 plus 4 11, 1.12, that is option number D here. Okay, next, the half-life period of a first order reaction is 60 minutes. What percentage will be left over after 240 minutes? Okay, so suppose you started with 100. Okay, with first 60 minute we got it 50, with next 60 minute we got 25, with next 60 minute we got 12.5, with the next 60 minutes, that is 60 into 4, 240, we will get 6.25. So how much percentage will be left? 6.25, that is option number A. Next, the rate constants K1 and K2 for two different reactions are given. The temperature at which K1 is equal to K2. This is also a very important question and a previous year question. So K1 is equal to K2. Let me write down K1 is equal to K2. So what is the value of K1? 10 to the power of 16 into e to the power of minus 2000 by t is equal to 10 to the power of 15 into e to the power of minus 1000 by t. Okay, next we can see 10 into e to the power of minus 2000 by t into e to the power of this I am dividing, or wait 1 second, what I will do is I divided this one on this side and I will get e to the power of minus 1000 by t divided by e to the power of minus 2000 by t. Okay, so 10 is equal to e to the power of 1000 by t. right? Now take ln 10 on both sides. Ln 10 will be equal to 1000 by T. Ln I can convert it as 2.303 log of 10 is equal to 1000 by T. So T will be equal to 1000 divided by 2.303. Okay, so that will be option number C. Clear? So students, let's see the next question here. The activation energy for the reaction A gives you B plus C at a temperature T Kelvin is given to you, which is 0.04606 RT. What is the ratio of the Arrhenius factor and the rate constant for this reaction? So first, let us start by writing the Arrhenius equation. K equal to A into e to the power of minus EA by RT. Next, log K is equal to log A minus EA by 2.303 RT. Okay. Now what I can do, I can substitute the EA value. So log K is equal to log A minus, what is EA? 0.04606 RT by 2.303 RT. Okay. So now we can cancel this RT and I can take this one on this side. So I'll get 0.4606 by 2.303 equal to log of A by minus log of K. Okay, so that is equal to log of A by K. Okay, so next log A by K, so I want to just divide this one. So I will have 4606 divided by 1, 2, 3, 4, 5, 10 to the power of 5. Okay, and I have here 2303 divided by 10 to the power of 3. Okay, so it is, I will get 2 into 10 to the power of minus 2. Clear? So what I am getting here, log A by K equal to 2 into 10 to the power of minus 2, or let me just write it as 0.02. Okay. Now what is A by K value then? It will be 10 to the power of 0.02, right? Now you may ask, ma'am, how to find this one? So you can easily find that based on the options. You do not have to even do any calculation. With clear some common guessing you can easily do. Now tell me that when I am saying anti-log of this number, okay, so which number's log value is 0.02, I have to find out. Okay, which number's log value is 0.02, that is what I have to find out. Now I know that log 1 is 0 and log 2 is 0.301. So this number 0.02 as a log value will be something in between 1 and 2, right? It cannot be less than 1, it has to be more than 1, less than 2, and between 1 and 2. So it cannot be less than 1. So I have this option less than 1, I have this option less than 1, I can eliminate these two. Now if you see 1 and 2, 1.5 comes exactly between them. So its value will not be this much less, that is 0.02. So when you have log 1 is 0 and I want to find a value whose log value is 0.02, that number will definitely be very close to 1. So if I see these two options, I can see that this number is very close to 1. So its log value will be 0.02. So that is why option number D here. Okay. Next question. In the presence of a catalyst at a given temperature of 27 degrees Celsius, the activation energy of a specific reaction is reduced by 100 joules per mole. What is the ratio between the rate constant for the catalyzed and uncatalyzed reaction? You have to find the ratio between the rate constants for the catalyzed and uncatalyzed reaction. So let us write down Kc, that is catalyzed reaction. Kc is equal to A into e to the power of minus EC by RT, and K uncatalyzed equal to EU by RT. Okay. Now let me just take the ratio of both of them. Okay. So that is Kc by Ku, and that will be equal to A will get cancelled, e to the power of minus EC by RT plus EU by RT, and that will be equal to e to the power of EU minus EC by RT. And this one, the difference in the activation energy is 100 by RT. Okay, and I have, so now what I can do is I can take log on both sides. So log of Kc by Ku, okay, will be equal to, what I can do will be equal to 100 divided by 2.303 RT. So what I am doing this one, so basically if you see here, I'll just erase this part, one second. So I was having this value, right? I am having this value, that is Kc by Ku is equal to e to the power of 100 by RT, that is there. I'll take ln on both sides, ln of Kc by Ku, that is equal to 100 by RT. Now if I convert it into log of Kc by Ku, that will be equal to, if I want to convert ln to log, it will become 2.303 log. So I have 2.303 log Kc by Ku, and that 2.303 I am dividing this side. So 100 by, okay, this is clear. Now 2.303 into R, please remember this values comes out to be 19.1. okay, so I have this value as 19.1 and temperature is 27, so that means 300 Kelvin. So I have 100 divided by 19.1, I am just taking it 19 into 300. So I will get 1 by 57. Okay, now if I solve for this 1 by 57, so what I got now, Kc by Ku, or I can just write down here, okay, I can write it like this, log Kc by Ku is equal to 1 by 57. Okay, and what is the value of 1 by 57? If I just solve 1 by 57, okay, 430 I got this one, then I can have 9 5s are 45, 9 is not there, 8 7s are 56, 8 5s are 40, that is also exceeding, 7 7s are 49, yes, 0.017 I can take, okay, 0.017. okay. Next what I can do is, so I want to find Kc by Ku, right, as I said, that will be equal to 10 to the power of 0.017. Now just I showed you in the previous question, log 1 is 0 and log 2 is 0.301. So this number will come somewhere in between and it should be closer to 1. So I have this one is less than 1, this one is less than 1, this is near to 2, this will be the answer, that is 1.04. Its value will be somewhere around to 0.02 or 0.017. okay. Next, moving to D and F block elements question. The number of moles of KMnO4 that will be needed to react completely with 1 mole of ferrous oxalate in the acidic medium is. Okay, so here you can see 1 mole of ferrous ion is there. So to react with that, how many moles of KMnO4 will be required? So if you write down the reaction of KMnO4, okay, so MnO4 minus gets converted to Mn2 plus, okay, plus 7 to plus 2. So I have 5 electrons and then I have 4 water and then I have 8 H plus. Okay. Next you have ferrous oxalate. So Fe2 plus will be oxidized to Fe3 plus with the loss of 1 electrons. Okay. Now you can see that here I have 5 electrons and here I have 1 electron. So to balance the equation, I will multiply this with 5. So now what will be my final equation? I am just writing like this. I will get MnO4 minus plus 5 Fe2 plus. Okay. Okay, I have one more question, that we also have oxalate ion, right? oxalate ions can also be oxidized here, right? So we will check that also, and based on the options we have to find out which is getting oxidized here. So I have here Fe MnO4 minus plus 5 Fe2 plus, then I have 8 H plus, okay, then I have Mn2 plus, then I have 4 water and 5 Fe3 plus. Okay, now according to this equation I can say that 1 MnO4 minus reacts with 5 Fe2 plus, or I can say that with 1 mole of, so I have to find out the number of moles of KMnO4 that will react completely with 1 mole of Fe2 plus. So if you see here, I can say that for 5 moles of Fe2 plus, I have 1 mole of MnO4 minus, okay. Then for 1 mole of Fe2 plus, it will be 1 by 5 moles of MnO4 minus, right? But that is not there in the options. So that means what? Some other species is also there which can get oxidized, that is your oxalate ion. If you see C2O4 2 minus, oxalate ions gets converted to CO2. Here what is the oxidation state of carbon? It is +3, and here it is +4, right? So +3 to +4, 1 electron is there, 1 electron oxidation is happening, but there are 2 carbons. So for 1 carbon 1 electron is there, for 2 carbons it will be 2 electrons, so I can write +2 electrons. Now to balance this equation I will multiply this equation. So now I am not worried about Fe2 plus now, because that is not there in the option, but I have taught you if Fe is there then also my children can do the question, right? Yes. So now if I just write in terms of oxalate, what it will be? You can see C2O4 2 minus gives me 2 CO2 plus 2 electrons, and this you have to multiply with 5, and this you have to multiply with 2. So now just if you see, I will get 2 MnO4 minus, I am just writing the LHS side, and I will get 5 C2O4 2 minus, right? With that I am getting 10 electron here, 10 electron here, so that will get cancelled. So now what I can write in the equation according to this, that you can see here that 5 moles of C2O4 minus is reacted or oxidized by 2 moles of MnO4 minus. Next 1 mole of C2O4 2 minus will be reacted by 2 moles of MnO4 minus, okay. So for oxidizing 1 mole of C2O4 I require 2 by 5 moles of MnO4, that is option number B here, okay. Next compound that is both paramagnetic and colored. So for paramagnetic and colored, what I need unpaired electrons, right? So in which of the following options we have unpaired electrons, you have to see. So chromium, if you see in this one, it is in +6 state, and in chromium in +6 has no unpaired electron. Next if I see TiCl6, that is titanium, is in +4, you can see NH4 stands plus, charge is +1. So I have 2 NH4, so 2 plus X minus 6 is equal to 0. So titanium, what is the electronic configuration? Titanium electronic configuration is Ar 3d2 4s2. Then titanium +4 will also be argon configuration with no unpaired electron. So this one will also be not colored. VOSO4 if you see, okay. So that one if you see, vanadium will be X, oxygen will be -2, sulfate ion is also -2, so that is also +4. Now scandium, titanium, vanadium configuration is Ar 3d3 and 4s2. So vanadium in +4 oxidation state will be, I will have 1 2 3 4, so that is 3d1, right? Now 3d1, there is 1 unpaired electron, so due to this 1 unpaired electron it will show color also, magnetic behavior also, so option number C will be the correct answer. Next A compound of a metal ion Mx plus has a spin only magnetic moment of 50 root over of 15. The number of unpaired electrons in the metal are. This is very simple, you know this. Root magnetic moment is n plus 2, right? Now this value is 15. So what can be the value of n so that I get this one, right? So if I take n is equal to 3, so what I will get? 3 into 3 plus 2, that is equal to 3 into 5, right? So n value should be 3, option number D here. Next, in dichromate, dianion, what are the bonds present? If you see dichromate, Cr2O7 2 minus, okay? So it is like this. It is like this, O7, right? Just a minute, okay. Okay, so now you can see that here these all oxygens are under resonance. You can see we can have resonance here, and then you can have resonance here. So these all bonds are of one type. These all bonds are of one type. Now this Cr and O are of different types. So I have how much? 6 CRO bonds are equivalent. Okay, 1, 2, 3, 4, 5, 6 are equivalent. So option number B here. Next, which of the following compounds of manganese is amphoteric in nature? So this you should know the properties of the manganese. So MnO2, where manganese has +4 oxidation state, that is amphoteric in nature. Next, the reaction for the stability of gadolinium 3+, okay, not reaction, sorry, reason for the stability of gadolinium 3+. So you can see the configuration of gadolinium, that is 4f7, 5d1 and 6s2. So if gadolinium 3+ will be there, so what I will get? 2 plus 1, this one. I will have these 3 electrons removed, 4f7 configuration, exactly half filled configuration. So it possesses half filled 4f subshell. Okay. Next, we have coordination compounds. Let us solve the questions from coordination compounds. First question, nickel combines with a uni-negative monodentate ligands X minus to form a paramagnetic complex of NiX4 2 minus. The number of unpaired electrons in the nickel and the geometry of this complex ions are respectively. So now if you see nickel, if I say this is a monovalent, means charge of X is -1. So what is nickel charge here? It will be +2, or I can say 3d8. Now if I draw 3d8, okay, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, nickel is having 3d8 configuration. Now what will happen? The number of unpaired electrons in the nickel and the geometry of this complex ion are. So you see, I want a paramagnetic complex and coordination number is 4. So for coordination number 4, what all geometries we have? We have one is sp3 hybridization and another I have dsp2 hybridization, and Cn is a, sorry, so now what will happen if it is a paramagnetic complex? So we cannot do pairing. If I do pairing of electrons, there will be no unpaired electrons. It is given that the compound is paramagnetic, so this one will remain as it is. Okay, so that is your 3d. Next I have 4s and 4p, so 4s and 4p. So these orbitals will combine to give me what? To give me the sp3 hybridization. So in sp3 hybridization, what is the geometry? Tetrahedral. And how many unpaired electrons are there? 2. So 2 and tetrahedral, option number A here. Next, the coordination number and the oxidation state of the element E in the complex. Okay, so you can see that these both are bidentate ligands, right? That means each ligand can form 2 bonds. So there are total 2 En, so one En will form 2 bonds, 2 En will form 4 bonds, and C2O4 is also a bidentate ligand, it can also form 2 bonds, so total we will have 6 bonds here. So the coordination number will be 6 and I can eliminate these 2 options. Next, what is the oxidation state of the metal? So let E be equal to X, then this is 0 and C2O4 charge is -2 and the charge of the complex is neutral, so X will be equal to +2. Okay, 6 and +2. Next, In which of the following octahedral complexes of cobalt will the magnitude of CO be the highest? So for magnitude of CO to be highest, we need a very strong field ligand. Okay, the stronger the ligand, better will be the splitting, or we will have highest CFSE value. So if you see in the spectrochemical series, CN is a very strong field ligand, so here there will be maximum splitting or maximum CFSE, option number B. Next, IUPAC name of the given compound. Now see, when I am writing this 3 and this 2, that means what? The complex must be in this form, whole 6, 2 plus, and I have this is 3 minus. When this is present in this form, okay, then you do crisscross to get the compound. Okay, so this will be the charge of each of the complex. Now if I want to name them, this one will be hexaamine, so I have hexaamine. Hexanitro is given wrong, hexaamine, none of the above is not there. So hexaamine nickel, what is the charge of nickel here? You can see this is X, this is 0, that is equal to 2, so I will get X is equal to 2. Next we have hexanitro, this is NO2 group, hexanitro cobalt. So here also you can see NO2 charge is -1, right? So I have X minus 6 is equal to -3, X will be equal to +3, and since it is a part of the negative ion, so it will end with cobaltate. So I have hexaamine nickel 2, hexanitro cobaltate 3, option number A is the correct answer. Next, which is true in case of FeCN6 -3 complex. So for that you should be knowing the what I'll say, the properties about FeCN6 complex. So Fe has an electronic configuration of 3d6 4s2. Now Fe3 plus will have how much? You can see the oxidation state of Fe, X minus 6 is equal to -3, X is equal to +3. So if I just want to remove 3 electrons, it will have 3d5 configuration. Now if I draw this 3d5 configuration, okay, yes, 3d5 configuration is there, okay, and I want 6 unpaired electrons, 6 empty orbitals. So Cn is a very strong field ligand, so what will happen? There will be pairing of electrons, so I will get these 5 electrons, I can pair up like this, 1, 2, 3, 4 and 5, okay. Next I will have D2, this side D2, and then this is your 3D, right, and 4s and 4p. These will combine to give you what? D2sp3 configuration. This will completely combine with each other, and I will get 6 new orbitals, okay, which is your D2sp3 hybrid orbitals, where we have Cn ligands will come and donate their electrons. Now what we have here, you have to calculate the properties. D2sp3 hybridization is there, yes, that is correct. It is paramagnetic, yes, I have 1 unpaired electron, so it is paramagnetic. 1 unpaired electron, that is also correct. So all the above are correct, option number D here. Next, which is an inner orbital complex. So generally you should be knowing that for inner orbital complex we generally need a strong field ligand, okay. If we have a strong field ligand, then we will get inner orbital complex, and if we have a weak field ligand, we get outer d orbital complex. But this is generally, not in every case. So I will be showing you all these options. FeCN6 just now we saw, that is D2sp3, so yes, it is an inner orbital complex. Next, if you see MnCN6 3 minus, Mn 3 minus, what is the charge? Mn 3 plus. Mn 3 plus charge is D4 configuration, right, and 1, 2, 3, 4. So 1, 2, 3 and 4. Now even if I want to just pair up, I need 1 unpaired electron, so I will pair up with 1. So here also I will get D2sp3 hybridization, so that is also there. When both are there, so the answer that can be possible is your all are correct. So here also cobalt is in +3 state. So if I see cobalt in +3 state, cobalt configuration is 3d6, right. So we have here, okay, 1, 2, 3, 4, 5 and 6, and then if I just pair up, because it is again C2O4 is a strong field ligand, so we will get like this, and here also I can use D2sp3 hybridization. All are inner d orbitals used, so all of them are correct. Okay. Next, a complex of platinum, ammonia and chlorine produces 4 ions per molecule in the solution. The structure consistent with the observation is. So you have 4 ions has to be produced. Now if I see this one, in this complex only 1 ion will be produced. Here also I will have only 1 ion. Here if I see that there will be 3 chlorine ions and 1 complex ion, so 4 ions will be produced in option number C. Here if I see 2 chlorine and 1 complex, so that is 3. Option number C is the correct answer here. Next, we have haloalkanes and haloarenes. Let's solve the questions from here. So first of all, we are treating this one with Mg dry ether. So that will give me a Grignard reagent. So what will be the product of A? A will be MgBr. Okay, and after that if I have CO2, that one, this negative charge will attack on this one, right, and this one will go. So I will get here COOH. Okay, so I will get what is B? B is your benzoic acid, that is option number A here. Next, CH3NH2 reacts with CH3MgX to give you. So here you can know CH3NH2 plus CH3MgX plus minus, okay, and here what I have CH3NH minus and H plus. Okay, so what you have to do, you have to combine minus plus and minus and plus. So this two will combine to give you CH3 minus and H plus, that is CH4, and this two will combine to give you CH3NHMgX. So the product I will get here is methane or CH4, option number B here. Okay, next we have a previous year question of 2024. 2-methyl propane can be prepared by Wood's reaction. The haloalkanes taken along with the sodium, along with the metallic sodium and dry ether. So if you remember, Wood's reaction is what? Rx in presence of sodium and dry ether gives me RR, right? So this is the RR value, or so I want to now prepare 2-methyl propane. Okay, this is the product that I want to prepare. So what all Rx I have to take? So you can see that here there is a branching. So I can take something like this, CH3Cl plus CCl. Okay, if this is present, then what will happen? This one will move out and I will get CH3, CH3, CH3. So that will be the product. So what I want? One I want is chloromethane and another one is 2-chloropropane. Okay, these two will react to give you this one. So option number A is the correct answer. Next, in the following sequence of reactions, you have to find the product. So I will tell you what is there if it is not visible, I think. So you have CH3, so just let me just write down this one, CH3, CH2, CH2Br. Okay, with that you have taken alcoholic KOH. Next you have taken A, then you have taken HBr, then you are getting B, then you are taking it with aqueous KOH, okay, and then there is a C. Okay, so now alcoholic KOH will give you what? There will be elimination reaction, HBr will be removed and we will get a double bond like this, CH3 CH double bond CH2. Now you are adding HBr. It is simple addition of HBr, no peroxide is given, so Markovnikov's rule will be followed and Br will be attacked to the carbon having less number of hydrogen. So what I will get here? CH3 CHBr CH3. Now with aqueous KOH what will happen? This Br will be replaced with OH. So I will get propane 2OL, that is option number D here. Next, alkyl halides on treatment with a suspension of moist Ag2O in ether gives you. So in this one, that is Rx, okay, with moist Ag2O, okay, Rx with moist Ag2O gives you ether, Okay, alkoxyalkane. So that is option number D here. Next, which compound undergo elimination easily? So elimination occurs via carbocation formation. Okay, so you have to see where the stability of the carbocation is maximum, there the elimination process will be faster. Now if I see here, if this goes out, okay, I'll get a carbon here, so this is a tertiary carbocation. Here if I see this Cl goes out, and here it will be a primary carbocation, and here also I will get a primary carbocation, and here I will get a tertiary carbocation, right? So now this is primary, this is primary, this is tertiary, and this is tertiary, right? So now I just want to draw the options once again. I think it might not be visible. So first one is like this. Okay, this is your option number A. Option number B is CH3, CH2 whole 2, okay, CH2Cl, okay. Next, option C is CH3, CH2 whole 2, CH2I, and option D will be CH3 whole 2, okay, and we have C, I, and CH2CH3. Okay, so this is there what is happening. Now you see here I will get a tertiary carbocation, here I will get a primary, here also I will get a primary, and here I will get a tertiary. So now both are tertiary. Now which bond will break easily? Next you have to check. So I can eliminate B and C. Here I bond will break easily because I size is very big, poor overlapping, weak bond. So this one will break easily, and that is why I will get option number D as the correct answer. Okay, next we'll move to alcohols, phenols, and ethers, the next important chapter. So question here is, a compound A, that is C7H8O, is insoluble in NaHCO3 solution but dissolves in NaOH and gives a characteristic color with neutral FeCl3 solution. So when it is giving you a neutral color and it is reacting with FeCl3 solution, that is a major indicator that we have phenol group. Okay, so A must be phenol group. Okay, but means phenol group is present. Okay, we have a molecular formula of C7H8, so I don't know, there will be another carbon will be there, but phenol group is there. When treated with bromine water, compound A forms compound B with the molecular formula. So just let me write down the molecular formula: C7H5 CBr, one second, yeah, C7H5O Br3. Okay, C7H5O Br3 compound is formed. Now what you can see here, that if I am reacting, so one CH3 group is there and definitely phenol is there, so that means I will get tribromo product, means I will get ortho, para and bromo product, right? Ortho, two ortho and para position will be occupied. So that means here bromine will be added, here bromine will be added, here bromine will be added. So the extra C which is there, that is your methyl group, must be present at the meta position. So that is your option number B. Okay, OH and CH3 are present at this position. Next, we'll move to the question number 38. Among the following, the products formed by the reaction of anisole with HI. So this is your cleavage of ethers. So if I have anisole, that is with HI, so what will happen? This bond will break always. This bond cannot break because of partial double bond character. So you will get here OH plus CH3I. Okay, so that is phenol plus iodomethane. Now let us see the next question here. So you have OH, NaOH, and you are giving it with CO2 and H plus. So first of all, whenever we have this phenol group with NaOH, it is an acid reacting with an base, so you will get salt and water. Okay, so what will be the A product here? It will be C. H will go out and H and OH will react to give you water, and I will be left with O minus and Na plus. Okay, now this CO2, I think now you can guess this is reaction, this is your Coles reaction. Okay, so what will happen, this one will react with this one and I will get OH and COOH. If you are not able to recollect, please check the Coles reaction. Okay, now after this, if I take CH3CO whole 2, so this is acylation, this OH group will be acylated to give you OCOCH3 and I have COOH. Okay, and this is your aspirin, or option number D is the correct answer. Next, I have a very good question, question number 40. See, 8.8 gram of monohydric alcohol. So monohydric alcohol means what? In that compound I have only one alcohol group is present. Added to ethyl magnesium iodide in ether liberates 2 to 4 centimeter cube of ethane at STP. So what happens when alcohols reacts with Grignard reagent? That is the first thing we have to know. When I have alcohol reacting with Grignard reagent, what happens? So this is plus, this is minus, this is minus, sorry, this is plus, this is minus, right? So I get a compound ROMgX. Okay, I will get RO, minus and plus will react. So ROMgX and I will react R and H. Okay, so now this is the alkane I am getting here. So now in the given question I have a monohydric alcohol, okay, and I am reacting it with what? Ethyl magnesium, that is C2H5Mgi, right, and that will give me C2H5H plus ROMgi plus C2H5H, that means C2H6. Okay, now they have given you that 20 to 4 centimeter cube of ethane is produced at STP. That means, can we get the number of moles of ethane? Why I am asking that? According to this reaction, I can say that 1 mole of ethane is produced by 1 mole of monohydric alcohol. Right? So if I can calculate the number of moles of ethane, I can also calculate the number of moles of alcohol, right? So that is why I have to calculate the number of moles of ethane. Now when volume is given, what is the formula for to calculate the number of moles of ethane? Number of moles of ethane will be given volume by molar volume. So given volume is 20 to 4 and the molar volume is 20 to 400. So I will get 10 to the power of minus 2. Number of moles of ethane is 10 to the power of minus 2. So that means I can also say that number of moles of alcohols will be 10 to the power of minus 2 or 0.01 number of moles of alcohols. Now one more question is there here. This monohydric alcohol when oxidized with pyridium chlorochromate, okay, there is something missed here, I am adding here, that this monohydric alcohol when oxidized with pyridium chlorochromate gives a compound which has positive tolerance test, okay, which gives positive tolerance test. So that means this must be a secondary alcohol, sorry, this must be a primary alcohol. So if primary alcohol is there and you oxidize it, you get an aldehyde, and that aldehyde will be reacting, will be giving you a positive test for silver. So I need, what hint I got about this monohydric alcohol, this one will be a primary alcohol. Why? Because primary alcohol, when it is reacting it with PCC, we are getting one aldehyde, and that aldehyde is giving you a silver mirror test. So from that I can rule out these two options. Why? Because these are secondary alcohols. Now we'll come back to our question. Here the mass, number of moles is equal to what? Given mass by molar mass, and I have the molar mass I can calculate from here. Molar mass will be equal to, that is 8.8 divided by 0.01, and that will give me 88. Now you have just left with two options, right? You have to check which mass is giving you 88. Let's check with option number B, that is 2,2-dimethyl propane 1-OL. So I have 2,2-dimethyl propane 1-OL. Okay, so let's just calculate the mass. 1 2 3 4 5, so 12 5s I have 60, plus hydrogen 3 3 3, that is 3 3s are 9, 10 and then 11. Okay, one second, 1 2 3 9 10, I have missed one. Okay, this hydrogen is not there, right? So CH3 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 and then COH. So I have total 10 hydrogens. Okay, one second. Yes, so I have 10 hydrogens and then I have one oxygen. So I can add here 1 2 3 4 5 3 3 3. So now we have to calculate that alcohol which will have a molar mass of 88. Let's check with option number B here, 2,2-dimethyl propane 1-OL. Okay, so if I have 2,2-dimethyl propane 1-OL, so CH3 CH3 H3 H2OH. Okay, so let's calculate the mass. 1 2 3 4 5, so 60 plus 3 3 3 3, so 12 plus 16, right? So this one will give me 88, and according to question the molar mass is also so we were also finding that the molar mass was 88, so the correct answer will be option number B here. Okay, next we have question that is increasing order of acidic nature. So you have propanol, 4-methyl phenol, phenol and 3-nitrophenol and 2-nitrophenol. So always remember that electron withdrawing groups will increase the acidity. Okay, electron withdrawing groups will increase the acidity. So I have, first let me draw the structure. I have first one is propanol, that is CH3 CH2OH. Then I have here something that is 4-methyl phenol. I have 4-methyl phenol, and then I have phenol. Okay, then you have which one, that is 3-nitrophenol. And the fifth one will be 3-nitrophenol, and then I have 2-nitrophenol. Okay, now what I can do, you can see that where electron withdrawing groups are present, here and here. So definitely these two will be more acidic, and whenever electron withdrawing groups are present, if they are present at ortho and para position, they withdraw by -R effect, okay, which is a powerful effect, and if they are present at meta position, they withdraw by -I effect, okay, which is a less prominent effect in comparison to -R effect. So now what will happen, if I see fourth and fifth one will be more acidic, so definitely fifth one is highest, and I have only one option with that, so I can easily say it is option number A. But let's check the other option. So here I have an electron donating group, so it will decrease the acidity. So but always remember that phenol is more acidic than aliphatic alcohols. Phenol is more acidic than aliphatic alcohol. So definitely propanol will be the least acidic. So 1 will be the least one, then we have 2 because of electron withdrawing group, then we have 3 because of no group, fourth we have -I effect, and fifth one will be -R effect. So option number A will be the correct answer. Next, increasing order of acidic strength among this one. So para-methoxyphenol is there. So I have phenol and I have para-methoxy group. Okay. Next you have para-methyl phenol. You have para-methyl phenol, and lastly you have para-nitrophenol. Okay. Next, let's see here. Nitro group is an electron withdrawing group. CH3 is an electron donating group. OCH3 is also an electron donating group. What is the difference here? This donates by +R effect, this donates by +I effect. Okay, so +R effect is more dominant, so it will donate more. Donate more means the acidity will decrease more. So this one will be least acidic, so 1 will be least acidic, and this one will be highest acidic because it is having an electron withdrawing group. So 3 will be the highest, in between 2, so option number D here. Okay, Next we'll see the question. So you have the cleavage of ether. Question is from like that, CH3O, CH3, CH3 and H. So you can see that this side I have primary group and this side I have secondary group. So whenever I have one primary, one secondary, or both primaries or secondaries, the mechanism followed is SN2 mechanism. In SN2 mechanism, what happens? The nucleophile will attack on the less hindered site. Nucleophile will attack on the less hindered site. Okay, so you can see this side there is less hindered, so I minus is present here, nucleophile, so it will attack on the less hindered side. So it will become CH3I, and this one will react with CH3, CH3, CHOH. So this one will be, product will be CH3I, where I am getting that, yes, CH3I plus CH3 whole to CHOH, option number D here. Okay. Next, we'll move towards the aldehydes, ketones and carboxylic acid chapters. The first question here is very important. The best suitable reagent for the following transformation. So you can see here, this CO group is reduced to CH2. So that is reduction of aldehydes and ketones to to hydrocarbons, and that is done by Wolff-Kissner reduction and Clemmensen reduction. And you can see both the options are there. Then which is correct? In this case, you have to see that this compound, okay, this alcohols are acidic in nature. So the medium should be basic in nature. Okay, so we should have a base in the medium. So that is why here KOH is the basic medium, HCl is the acidic medium, so I will have option number A here. Next, the order of reactivity of pH, Mg, Br with. So order of reactivity, so always remember what is the order. Aldehydes are more reactive than ketones. Okay, so I can have, this is an aldehyde, these two are ketones, so definitely 2 is more reactive. So I have only one option with that, so that will be the answer, but let's see the other. Now here, so that means what? Steric hindrance, less is the steric hindrance, more is the reactivity. So I have here CH3 group, here CH3 group, right? 2 CH3 groups are there, and here I have 2 pH groups which are bulkier group. So here the reactivity will be faster than this one, because this is less bulky, this is more bulky. So that is why after 2, 3 will have, after 3 we will have 1. Option number C will be the correct answer. Next, which one is most reactive towards nucleophilic addition reaction? Now if I want to add a nucleophile, okay, suppose a species is there and you want to add a nucleophile to this one. So this species should be an electrophile, then only this nucleophile can attack on this one. So out of these all options, I have to check where the electrophilicity is maximum. And one more thing I have to check here, that aldehyde or ketone, if it is there, then aldehydes will react faster than ketone. Okay, so here I can see there is an aldehyde, here there is an ketone, so this will react slowest, so I can eliminate this one. Here I have aldehyde, here also I have aldehyde. Okay, after that what I should check, this reactant should be electrophilic in nature, because a nucleophile is attacking. So if the ring is more electron deficient, this attack will be faster, right? So here I don't have anything. Here I have an electron donating group, and here I have an electron withdrawing group. So now electron withdrawing group is there, it will pull the electron towards itself. That means this carbon will become more and more electrophilic in nature, right? So nucleophile will attack faster here, so option number D. Next, upon reductive ozonolysis of 2-methyl-but-2-ene, the compound obtained are, you have 2-methyl-but-2-ene, okay, 2-methyl-but-2-ene, and we are breaking it. So what will happen? You have to just add oxygen on both sides, so it will be like this. Okay, so I will get acetone and ethanol, so mixture of ethanol and propanol, that is option number D here. Next, the IUPAC name of the aldol formed by the reaction of acetaldehyde with dilute alkali. So acetaldehyde if I have, okay, with dilute alkali, okay, so that is CH3 C double bond OH and then I have CH3 C double bond OH. What you have to do now, I have told you a trick. If you remember, what you have to do, you have to consider this alpha carbon, okay, reduce its hydrogen, connect this carbon to the carbonyl carbon, and that H what you have reduced here, add that H here, and this bond is created, so this bond you remove. Okay, so what will be the product? I will get CH3 CHOH CH2 COH. Okay, so what will be the answer here? 3-hydroxy butanol, that is option number B. Let's see the next question, number 48. CH3CHO and C6H5CH2CHO can be distinguished chemically by. So if you remember, if I have this CH3CO group, okay, this group is very special. What is it? Remember, it is very special. Why? This group is very special. Special spelling is wrong, please ignore. This group is there, or if I have CH3CHOH, ma'am, if this group is present, if these two groups are present, it is very special molecule because they will react with iodoform test and they will give you a yellow precipitate. So I have this compound in CH3CHO and in C6H5CH2CHO, that is not there. So I can distinguish them using iodoform test. What is the iodoform test? Whenever you have this methyl ketone, we call it a methyl ketone, okay, here anything may be present, plus NaOI, or I can write it like I2NaOH, okay. If this is present, what happens? This bond breaks here, okay, and these groups convert to iodoform, which is a yellow color precipitate, and this group gets converted to acid, okay. So now I can see how can I distinguish them? Definitely CH3CHO, option number B. Okay. Next question. If this question is visible, it is your aldol condensation first part. Then you have to treat it with HCN and H3O plus. What will be the product? So for aldol condensation, let us apply my trick. What is it? You have to do HC double bond OH. Next, below that you write down the other compound. Okay, now you may ask a question, ma'am, why not this one up and why not this one down? You see here there is no alpha carbon, okay, no alpha carbon is there. So always what happens, the alpha carbon will attack on the carbonyl carbon. So this one cannot attack on this one because there is no alpha carbon. Alpha carbon means the carbon next to the CO group, that will attack on the carbonyl carbon. Clear? So abhi now this one is there, this group will attack on this one, right? Next step is what? Remove one hydrogen here, add one hydrogen here, this bond is formed, so this bond will be removed. So what I will get? This is the product I have got initially, okay. Now after that heat is also given, means dehydration will take place. So remove this OH, remove one more H and just make a double bond here, okay. So what I will get? CH2 CH C double bond OH, okay. This is my A product, okay. CH2, okay, here there is a double bond, sorry, CH2 double bond CHCOH. Now if you are treating with OH and HCN, so what will happen? This one will attack here, HCN, CN minus will attack here, this bond will go here, OH and CN will form. So I will get CH2 CH COH CN and H. After that you are doing hydrolysis, so this CN will get converted to COOH, okay. So what I will get? CH2 double bond C, then I have COH COH, that is option number A here, okay. Next we have another question, C6H5COH with ammonia and heating, that will give you amides. So what will be P here? P will be C6H5 double bond O NH2. Next NaOBr, this is your Hofmann bromamide degradation, so this group will go out, okay. NaOBr is what? We are getting this one from Br2NaOH, okay. Hofmann bromamide degradation, this CO group will go and I will get C6H5NH2, okay. then I have got aniline here, right? Aniline here. Next, if you treat it with H2SO4 and heat, you will get SO3H added at the ortho and para position, and this compound is called as your sulfanilic acid. That is option number C. Okay. Next, we'll move to amines chapter. Okay. Amines chapter, first question. If aniline is treated with a mixture of 1:1 concentrated HNO3 and concentrated H2SO4, para-nitroaniline and meta-nitroaniline are formed in nearly equal amounts. So, if you know that any electron donating group, it generally directs the incoming group to the ortho and para position, right? Now, but in case of aniline, if I take aniline, okay, aniline is this one, and if I just treat it with HNO3 and H2SO4, in that what will happen? H plus is present, this NH2 get protonated, and what I get when this one get protonated? NH3 plus I will get if it is protonated. Now this NH3 plus is now a electron withdrawing group. Why? Because it can attract ring from the electrons from the ring. So it is an deactivating group, okay, and that is why it will be meta directing, right? So that is why we get meta product as also. So the protonation of NH2 group which causes the deactivation of benzene ring, option number D. Okay, next you have to find the product here. So first of all, NO2 and Br2 FeBr3 is there. So that is what normal bromination happens, and NO2 is an electron withdrawing group, so it will be meta directing, right? So where this bromine will attack? It will attack at the meta position. So what will be my P? You will have NO2 and then Br. Next, Sn and HCl. Sn and HCl will convert this NO2 to NH2. Reduction is there. So what will be Q here? NH2 and Br. Okay. Next, NaNO2 and dilute HCl, that is nitrous acid. When you treat aniline with nitrous acid, you get benzene disonium chloride. So this NH2 will get converted to N2 plus and Cl minus with bromine at the meta position. Now you are giving warm water. So with warm water, what will happen? This N2 plus will be converted to OH. Okay, so I will get what? Meta-bromophenol, and that is option number A here. Clear? Next, a hydrocarbon A C4H8. Okay, so let us write down. We have one hydrocarbon A, that is C4H8, reacts with on reaction with HCl gives a compound C4H9Cl. Okay, it gives a compound on reacting with HCl C4H9Cl. Okay, which on reaction with 1 mole of NH3 gives a compound C4H10NH2. So if I reacting with NH3, I get C4H10N. Okay, on reacting with NaNO2 and HCl, okay, followed by treatment with water, compound C, so this is A, this is B, and this is C. Compound C yields an optically active compound D. Okay, so now if you just imagine, you are taking C4H10, means it is a aliphatic amines, you can guess from here, and if you are treating with NaNO2 and HCl, you are getting amines converting to alcohols, right? Aliphatic amines with NaNO2 and HCl or with nitrous acid gets converted to aliphatic amines, gets converted to alcohols. So I will get an alcohol. So D is definitely one alcohol product, and I have only one option with alcohol product, and sorry, so that is why correct answer will be option number B. Okay. Next, which of the following is more basic than aniline? More basic than aniline, if I want to find out. Okay, more basic than aniline means, if I just draw the structure, diphenyl aniline. So I have diphenyl aniline. This is one compound. Okay, next triphenyl aniline, you have 3 phenyl groups attached here. Okay, next we have para-nitroaniline, we have para-nitroaniline, and lastly I have benzyl amine. Okay, now see, in all the structures here nitrogen electron pair is involved in resonance, right? It is involved in resonance. Here also it is involved in resonance, right? But here the nitrogen is not involved in resonance, it is available for donation, right? So what I can say, this N can be donated, or it is not available for, it is available for donation, it is not involved in resonance. So I can say that benzyl amine will be more basic than aniline, because in aniline what happens, the lone pair of nitrogen is involved in resonance. Okay, next, the correct increasing order of basic strength of para-nitroaniline, para-bromoaniline and para-toluidine. So we have aniline, the first one is para-nitroaniline, right? Next we have para-bromoaniline, yes. Next we have para-toluidine. Okay, so what we can do here, we need groups, right? Electron donating group. CH3 is an electron donating group, so it will increase the sorry, this is NH2, it will increase the electron density, so the basicity will increase for third one. So I have this one and this one. Next, NO2 is an electron withdrawing group, but it withdraws by minus R effect, this withdraws by minus I effect. Okay, so minus R is more effective or more prominent, so more electron will be withdrawn here, so this one will be least basic. So 1, 2 and then 3, so option number C here. Okay, next we'll move to biomolecules chapter. Okay, riboflavin is the chemical name of, so riboflavin is the chemical name of vitamin B2, so option number B. Which of the following is a non-essential amino acid? So you should remember all the 10 essential amino acids, and proline is a non-essential amino acid, so option number D. Next, the pH value of the solution in which a particular amino acid does not migrate under the influence of an electric field. So you know that pH at which the amino acid exists in the form of Zwitter ion, that pH value is called as your isoelectric point, or option number D. Next, deficiency of vitamin B1, okay, causes which one? That is beriberi. So please, this table is very important. Go through the table given in NCERT book, where all the vitamins, their sources and their deficiency diseases have been mentioned. You have to revise that table thoroughly. Okay. Next, moving to question number 60, incorrect statement among the following. The most abundant biomolecule in the living system are proteins. That is correct. Proteins are required for the growth and maintenance of the body. Yes, definitely. Hydrolysis of proteins gives you alpha amino acids. Yes, that is also correct. Next, I have this one. Polymerizes to give you a protein. This is amino acid, yes, but this is not an alpha amino acid. What is the structure? All the proteins are made up of alpha amino acids. Now what is the structure of alpha amino acid? Okay, so now this one, to this carbon we have COOH and NH2, right? To the same carbon both are attached. That is why this is alpha amino acid. But here you see, to the same carbon COH and NH2 are not attached. This is a beta alpha amino acid, beta amino acid, and beta amino acid does not give you protein. Alpha amino acids gives you protein. So that is why I have option number D here. Okay, let us see the next question here. Okay, the fifth carbon in the glucose has hydrogen on the left, hence glucose is D compound. Yes, that is correct. Oh, just a minute. This is a correct statement. Anomeric carbon has H on the left, that is also correct. Glucose has cyclic acetal structures with its CHO group. Yes. Now when there is cyclic acetal structure, there is no CHO group left, right? So it doesn't have this compound. This is the wrong statement. So option number C is the Correct answer. Beta D glucose has more melting point than alpha D. That is also the correct statement. So students, now we have done with PU2 chapters. Now let's quickly revise the PU1 chapter, some important questions. Okay, coming to chemical bonding, it is the most high weightage topic from PU1, so we cannot ignore this chapter. Okay, so the percentage of S character in the hybrid orbitals of sp, sp2 and sp, okay, this I think would be sp3 actually, follows the order. Okay, so if you see that in sp, okay, there is total 2 orbitals, so if I have 100% divided by 2, it will be 50%. So sp will have maximum percentage, then sp2 will have 3 orbitals, right, that means 100 divided by 3, so 33.33 all of them will get, and sp3 is having 4 orbitals and s percentage will be 25. So I have option number B here. Next, moving to question number 62, the molecular species having the highest bond order. So how to find the bond order? We have a very special formula here. What you have to do is, you have to take for 14, this is the total number of electrons. For 14 the bond order will be 3, then 2.5, here it will be 2, here it will be 1.5, and here it will be 1, here it is 2.5, here it is 2, here it is 1.5, and here it is 1. Now I have to calculate the bond order O2, that is 8 plus 8, 16, and for 16 the bond order will be 2. Okay. Next, O2 minus 8 plus 8, 16 plus 1, 17. So for 17 the bond order will be 1.5. Then O2 plus 8 plus 8, 16 minus 1, 16 minus 1 is 15. 15 bond order will be 2.5, and here again 16, 17, 18, and for 18 the bond order is 1. So I can find the maximum bond order is present in O2 plus, so option number C here. Next, the formal charges on oxygen atoms in O3 molecule. So what is the formula to calculate formal charge? So if you remember, formal charge is equal to total valence electrons minus half of bonding electrons minus non-bonding electrons. Okay, so I will get here for ozone, what is the structure? I have like this. Okay, 1, 2, 3, 4, 5, 6. Sorry, ozone structure is like this, 1, 2, 3, 4, and here I have one like this, and here I have like this. Okay, this is the structure of ozone. So let me O1, O2, and O3. Now what is the formal charge of O1 if I want to calculate for O1? So what is the total valence electron for oxygen? It is always 6 minus, I have non-bonding electrons, how much? 1, 2, 3, 4, 5, 6. So non-bonding electrons, and how many bonding electrons are there? 2, right? 2 by 2, that means 1 minus 6. So I will get here total charge will be minus 1. So this particular first oxygen formal charge will be how much? Minus 1. Okay, now let's calculate for O2. Okay, you can see the valence electron is 6. Okay, now how many bonding electrons are there? Bonding electrons are 1, 2, 3, 4, 5, 6, right? So 6 by 2, that will give me 3. And then non-bonding electrons are 2, so minus 2, so that is equal to plus 1. So this charge is plus 1. Now if I compare this oxygen O3, right, O3, what is the valence electron? 6 minus bonding electrons are 1, 2, 3, 4, right, 4 by 2, and non-bonding electrons are again 4. So I will have here 6 minus 6, 0, so that is 0. So I have now plus 1, there is no 2, right, so I have only one option, plus 1, 0, and minus 1. Okay, next question number 64, bond angle in pH 4 plus is more than that of pH 3. This is because, so if you see the structure of pH 3, what is it? It is having like this structure, so there is a repulsion between lone pair and bond pair, whereas in pH 4 the structure is like this. Okay, so there is no repulsion between lone pair and bond pair, so this is a perfect tetrahedral. This is a distorted tetrahedral, or we get the bond angle here because of this repulsion. These bonds come closer to each other, and once they come closer to each other the bond angle decreases. Okay, so I can say that why is it happening, that lone pair bond pair repulsions exist in pH 3, so option number D here. Next, which of the following pairs contains two lone pairs of electron on the central atom? Okay, so if I see H2O, it is like this. It has two central atoms, so this is there. Then let me talk about I3 plus. So if I have I, okay, central atom I has 7 valence electron. Now I3 plus means there will be 6 valence electrons. So I have 1, 2, 3, 4, 5 and 6. So I have I here and I have I here. Okay, now I have 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4 and 5, 6. Okay, so now you can see on the central atom I have two lone pairs of electrons. So now this one will be also having two lone pairs of electrons. So option number A here. Next, arrange the following in the increasing order of their bond order. So again we can follow that mechanism: 14, 15, 16, 17, 18, 13, 12, 11, 10. So for 14 the bond order is 3, this is 2.5, 2, 1.5 and 1, and here it is 2.5, 2, 1.5 and 1. Now what will happen? I have here O2 2 minus, right? So 8 plus 8 16, 17, 18. So this one O2 2 minus will be 1. Okay, next O2 minus 8 plus 8 16 plus 1 17, that is O2 minus is equal to how much? 1.5. Okay, next O2 plus 16 and then minus 1 15, so that is 2.5. okay, and we have O2 8 plus 8 16 and that is 2. Okay, so now what I can get, so you can see the highest bond order is between O2 plus, right? In the increasing order means O2 plus will come at the end, then I have 2, that is my O2, then I have O2 minus and then O2 2 minus, that is option number D. Next, we'll move to next important question, thermodynamics. Every year one question will be asked, so you should be knowing about the formula of W here. What is it? Minus 2.303 nRT log of V2 minus V1, and one more formula, delta H is equal to delta U plus T delta, delta U plus delta NGRT, this formula, and then delta G is equal to delta H minus T delta S. These three are the important formulas for this chapter. Moving towards the first question, the work done when 2 moles of an ideal gas expands reversibly and isothermally from a volume of 1 liter to 10 liters at 300 Kelvin. So I told you this formula is very important. So I can write down minus nRT log of minus 2.303 nRT log of V2 by V1, right? So I have minus 2.303 into, what is N value? N value is 2, R value is 0.0083, okay, then temperature is 300 and log is 10, V2 by V1, log 10 will be 1. So what I will have here, minus 2.303 into 2 into 0.0083 into 300. Okay, so what I will get here, just if I do a rough calculation, so 2.3 I am just taking, 2.3 into 2 will be 4.6, 4.6 into 300, so it is 3 and I am multiplying this 100 with this one, so 0.8, so 3 6 are 18 and 3 4s are 12, 138, 13.8 into 0.8 if I multiply, 8 8s are 64, 8 3s are 24 plus 6 30, 8 1s are 8 plus 3 11, with 2 decimal place, 11 point something I will get, so that is option number C here. Okay, next moving to question number 68, the reaction in which delta H is greater than delta U. This is also very important question. We have this formula, right? Delta H is equal to delta U plus delta NGRT. right? And I want a condition where delta H is greater than delta U. So in that case, you should know that delta Ng should be positive. If delta Ng is positive, that means if I add these two numbers, then I am getting a bigger number. So obviously delta H is bigger than both of this number, and delta H will be bigger than delta U also. So in which option I will have delta Ng positive? So here it is 2 and here it is 1 and 1. So 2 minus 2 is 0, delta Ng is 0 here. And in this case it is 1 and here it is no gaseous molecule, so 1 minus 0, 1, so delta Ng is equal to 1 here. G stands for gaseous molecule, so you have to, what is delta Ng? Delta Ng, number of gaseous moles of products minus number of gaseous moles of reactants, right? Next we have 2 here and 3 plus 1, 4, so 2 minus 4 is minus 2, minus 2. Next I have here 2, this is liquid, we can eliminate. I have 1 here and I have 3 here. So delta Ng is equal to 1 minus 3, that is equal to minus 2. So which is positive? Option number B here, okay. Next, the bond enthalpies of A2, B2 and AB are in the ratio of 2, 1, 2, okay. So A2, B2 and AB ratios are what? 2, 1, 2, or I can write 2x, 1x and 2x. Now if the bond enthalpy of formation of AB is 100 kilojoule per mole, bond enthalpy of formation of AB. So I have A2 plus B2 gives 2AB, okay. Bond enthalpy of formation of AB is 100 kilojoule, then the bond enthalpy of B2 is. So I can write the bond enthalpy for formation of AB is equal to, what will it will be? Bond enthalpy of A2 plus bond enthalpy of B2, right, minus 2 times of bond enthalpy of AB, okay. And this side what is it? Delta H of the reaction, or delta H of formation of AB. Okay. Now you see that enthalpy of formation of AB is minus 100 kilojoule per mole. That is for formation of 1 mole of AB. In my equation I am writing 2 moles of AB. So for 1 mole of AB it is 100 kilojoule. For 2 moles it will be minus 200 is equal to, what is the bond enthalpy of A2? That is 2x. Bond enthalpy of B2 is x, and minus 2 into bond enthalpy of AB is 2x. Okay. So what I will get? 3x minus 4x minus x, and that is minus 200. So what is x value? 200. The question is asked you to calculate the bond enthalpy of B2, which is x, and that is 200. So option number C here. Okay. Next, if the bond energies of HH, BR, BR and HBr are 433, 192 and 364 kilojoule per mole respectively, then the delta H for the reaction is. So I can write delta H for the reaction will be equal to, whenever you have bond enthalpies, it is always products minus reactants minus products. So that means I will have here bond enthalpy of H2 plus bond enthalpy of Br2 minus 2 times bond enthalpy of HBr. Okay. So now what I can put, what is the bond enthalpy of H2? 433 plus bond enthalpy of Br2 192 minus 2 times bond enthalpy of HBr, that is 364. Okay. So I have 3 plus 2 5, 9 plus 3 12, 4 5 6 25 minus 2 4s are 8, 2 6 are 2 6 are 12, 2 3 are 6 plus 1 7 28. Okay. So 8 minus, just let me check this multiplication. Yes. So 8 minus 5 is 3, 2 minus 2 is 0, 7 minus 6 is 1. So I will get minus 103, that is option number D here. Okay. Why I am multiplying 2 here? Because in the equation I have 2 HBr. Okay. For 1 molecule or 1 mole it is 364. For 2 moles it will be this 2 into that much. Now moving to the next chapter, that is equilibrium. Here also we can get a good question. One question definitely you can get in chemical equilibrium. Let's see the question. At 500 Kelvin for a reversible reaction in a closed container, the Kc value is given. In the presence of a catalyst, the equilibrium attains is 10 times faster. The equilibrium constant Kc in the presence of the catalyst at the same temperature is. This is very interesting question. So remember, whether you use catalyst or do not, the equilibrium constant do not change. It is a constant value, right? So it is not affected by catalyst. So whatever was there without catalyst, the same value will be there with catalyst. Option will be D. You don't have to waste a single second in solving this question. It will be the same value. Next, 1 mole of HI is heated in a closed container of capacity 2 liter. At equilibrium, half a mole of HI is dissociated. The equilibrium constant of the reaction is. So if HI is dissociating, okay, what will be the reaction? Okay, now 1 mole of HI is taken at T equal to 0. I have 1 mole of HI. Next, what will happen? At equilibrium, half of the mole of HI has dissociated. Half mole of HI has dissociated. Means at equilibrium. So now you see 2 moles is giving you H2, 1 mole. So 0.5 mole will give you 0.25 moles. Okay, and this one will be 0.5. That will be there. Once again I am repeating. See, from 1 mole, half mole has dissociated. If 1 mole will dissociate, means how much is dissociating? Half of that will be H2, half of that will be I2. So if 1 mole was taken, half of that is 0.05. So 0.05 mole dissociated. 0.05 mole after dissociating, half of 0.05 will be H2 and 0.25 will be I2. Now what is the concentration of HI at equilibrium? You can have 0.5 number of moles divided by volume, right? And the concentration of H2 will be equal to concentration of I2 will be equal to 0.25 divided by 2. Now if I want to calculate K equilibrium, it will be H2 concentration I2 concentration HI to the power of 2. Now H2 will be what? 0.25 by 2, I2 will be 0.25 by 2, and then HI will be 0.5 by 2 and 0.5 by 2. Okay, we can cancel these all things. So 5 5s are 0.25, so 1.25 I can cancel. I will be left with 0.25. That is option number A here. Okay, next, the equilibrium constant K1 and K2 for the following equilibria are related as. Okay, so first reaction, if you see, how can I obtain the second reaction from the first reaction? So let the first reaction is K1, this is K1, okay. Now this is K2. So first what I have done, this first reaction, you can see NO2 is on the right hand side. In the second equation, NO2 is on the left hand side. That means this reaction is reversed. When I reverse the reaction, the equilibrium constant becomes inverse, right? So for this one, when I am writing, suppose NO is giving NO plus half O2, NO plus half O2 gives me NO2, okay. Now when I reverse this reaction first, I will get NO plus half O2, and that will become 1 by K1, okay, after reversing this one. Next we are multiplying 2 to the whole equation, okay. Now when I multiply 2, what will happen? It will become square, right? 1 by K1 square. So what I can say, K2 will be equal to 1 by K1 square. Okay, do I have that option? Okay, or else I can say in other words that K2 root over is equal to K1. Okay, that is there. K1 is equal to root over of K2. So option number A here. Next, the conjugate base of NH3. Now see, if this is, I want to find conjugate base of something. What is the property of base? To accept H plus, right? So conjugate base of this one means you have to add H plus to that. So if I add NH3 or 1 H plus to that, it will become NH4 plus. Okay, so option number D will be there. Okay, conjugate, okay, sorry, 1 second, I did a small mistake. Conjugate base of this one, right? So this one should behave as what? Acid. You want to find the conjugate base of something. Conjugate base is for acid, right? Acids after donating their H plus whatever is formed, that is the conjugate base. So conjugate base of this one means it will behave as an acid, it has to donate H plus, so it will give you NH2 minus, that is option number C. Next, a weak acid with pKa 5.9 and a weak base with pKb 5.8 are mixed in equal proportion. The pH of the resulting solution is. So when I have a weak acid and weak base, if you are mixing them, salt hydrolysis we get, and the salt hydrolysis formula for weak acid and weak base is equal to 7 plus half pKa minus half pKb. Okay, so I have 7 plus half. What is pKa value? pKa is 5.9 plus half, sorry, not plus, that is minus half pKb is your 5.8. okay, so I can substitute 7 plus 2 2s are 4, 1, and then 2 9s are 18, sorry, 2 9 5 I'll get, 2 5s are 10, 2 9s are 18 plus 1 19, 2 2s are 4 plus 1 5, minus this one, 2 2s are 4, 2.9, right? Okay, so I can have 9.95 minus 2.9, so I will get here 7.05, that is option number D here. Okay. Next, the solubility product of CaC2O4 at a given temperature in pure water is given to me. The solubility of CaC2O4 at the same temperature is. So if you have CaC2O4, okay, how will it dissociate? Ca2 plus and C2O4 2 minus, S and S. Okay, what is Ksp value? That is equal to S square. Right, now Ksp value is how much? 4 into 10 to the power of minus 9. Okay, that is S square. So what is the value of S? Root over of 4 into 10 to the power of minus 9. So now that will be equal to how much? I can write it as, just I want to make this one a power so that it is divisible by 10. So I can make it as 40 into 10 to the power of minus 10, right? Yes, root over of that is equal to S. Now 10 to the power of minus 10 will give me 10 to the power of 5. Now you know 6 square is 36, right? And 7 square is 49. So it will be somewhere between 6 to 7, a number between 6 to 7 into 10 to the power of minus 5, and that is 6.3. So option number is A. Okay. Next, question number 77, the solubility of AgCl will be least in. So if you remember something called as common ion effect, okay. So I want to dissolve AgCl, okay, and in the solvent, if already chlorine is present, then the solubility of AgCl will decrease. Now if I see here, chlorine I have, and here I have 2 chlorines, here I have 3 chlorines, here I have no chlorine. So here already more number of chlorines is present, so the solubility of the AgCl will be least where already more chlorines are present. That is your common ion effect. So that is why option number D here. Okay. Next, we'll move to periodicity or periodic elements, the correct order of the first ionization enthalpy of the given elements. This is very, very important question. So what happens generally? If I move along the period, the ionization enthalpy increases, right? So lithium, if I see, I have lithium, then I should have beryllium, boron, carbon, and then nitrogen, right? But okay, lithium, up to carbon only the story is there, no nitrogen is involved. But here what happens, if I see the beryllium configuration, it is 1s2, 2s2, and here it is 1s2, 2s2 and 2p1 for boron. So now what happens, if it, here you can see that I have to remove electron from a noble gas configuration of helium or from a filled electron orbital. So that will require more energy. So that is why there is an exchange here and the order becomes like this, then carbon. Okay. So lithium, boron, beryllium, carbon, that is option number A here. Next, for one of the element, various successive ionization enthalpies are given below. So I have 577.5, 1810, 2750, 11550, 14820. Now what do you observe here? If you see that from first to second there is an increase of almost almost I can say up to 1000 times it increase, right? Not means 500 plus 500 plus 500 means almost 1500 times it increased. Here you can see 1800 to 2700, there is a increase, similar increase, but here I see a drastic increase, right, from 2000 to 11,000. Now why does that happen? That is because when I am removing the fourth electron, I am removing the electron from a noble gas configuration. That is why already stable and you have to put a lot of energy to break that stability. So which can be that element? So always if I want to remove 3 electrons easily, means 3 valence electrons should be there. And in group 13, that is in aluminium, we have, what is the configuration of aluminium with 13 atomic number? 1s2, 2s2, 2p6, 3s2, then 3p1. So I can see 6, 7, 8, 9, 10, 11, 12. Now if I can remove these 3 electrons, now when I am removing the fourth electron, it is from this noble configuration of neon, which is not an easy task. So that is why this ionization enthalpies values are for aluminium. Okay. Next, which of the following is the correct order of radius? So this you should always remember, anions will have more radius, then neutral atoms, and then cations. And in anions, the more the negative charge, okay, more negative charge, more size, okay, and in cations it is reverse, more positive charge, it is small size. Okay, so here you can see cation cannot be larger than anion, so it is wrong. Here I can see anion is there, but this is more negative charge, right? More negative charge means more size, so O2 minus should come first. Here if I see again negative charge should be at the starting, so this is also wrong. Here I can see negative, neutral, positive, so that is the correct order, option number A here. Next, some basic concepts of chemistry, the first chapter. The number of electrons in one mole, in a mole of hydrogen molecule. So if I see in one atom, in one molecule of H2, okay, one molecule of H2, how many electrons are there? 2 electrons. Now it is asking for in one mole. 1 mole means 6 into 10 to the power of 23 molecules. In one molecule it is 2, so in this one it will be 2 into 6 into 10 to the power of 23, that is equal to 12 into 10 to the power of 23, or I can write that is option number B here. Okay. Next, a pure compound contains 2.4 gram of carbon, 1.2 into 10 to the power of 23 atoms of hydrogen, 0.2 moles of oxygen atoms. Its empirical formula is, okay, so I have C, I have H, and I have O. Okay, so you have 2.4 gram of carbon, so it is 2.4 divided by 12 and the number of moles will be 0.2. For hydrogen it is 1.2 into 10 to the power of 23 by 6 into 10 to the power of 23. So here it is also 0.2. Then 0.2 moles of oxygen. It is already given 0.2 moles of oxygen. So what is the ratio here? It is 1:1:1. So the molecular formula, the empirical formula will be CHO, option number D here. Okay. Next, 0.4 gram of dihydrogen is made to react with 7.1 gram of dichlorine to form HCl gas. The volume of HCl formed at 273 Kelvin and 1 bar pressure is. Okay, so now if I see H2 plus Cl2 gives me 2 HCl, right? And if I just write down here 1 mole of HCl, H2 reacts with 1 mole of Cl2 to give me 2 moles of HCl. Right. Now if I see 0.4 gram of dihydrogen, so 0.4 by 2 it will be 0.2. So H2 is given to me in the question, 0.2 moles. And for chlorine it is 71 by 7, dichlorine molar mass is 71. So 7.1 by 71, that will be again 0.1. Right. So 1 mole of chlorine gives me 2 moles of HCl. This is the limiting reagent, right? H2 will be in excess. So I can say that 1 mole of Cl2 gives me 2 moles of HCl. So 0.1 mole of this one will give me 0.2 moles of HCl. Now you have to convert it into volume. So 22.4 into 0.2. 2 4s are 8, 2 2s are 4, 2 2s are 4, 4.48 liter I will get. Okay, so that will be near to 4.54 because this 22.4 liter can be sometimes taken with some near numbers also. Okay, so nearest answer will be option number A. Next, 0.3 gram of an organic compound containing C, H and O on combustion yields 0.44 gram of CO2, 0.18 gram of H2O. If 1 mole of the compound weighs 60 gram, then what is the molecular formula of the compound? This is also a very good question. Now see, I have 0.44 gram of carbon dioxide. Okay, so I can say that in 44 grams of CO2, okay, how much carbon is present? 44 gram. Why I am taking? The molar mass of CO2 is 44, right? So in 44 gram of CO2, I have 12 grams of carbon. In 1 gram of CO2, I have 12 by 44. Okay, in 0.44 gram of CO2, how much will be? It will be 0.12. Right? 0.01. So 0.12 moles. 0.12 grams of carbon dioxide is there. Carbon is there. Right? Now if I want to calculate the number of moles of carbon, 0.12 by 12, that is 0.01. Number of moles of carbon is 0.01. Next, let me calculate the number of moles of hydrogen. So I can say that in 18 gram of water, there is 2 grams of hydrogen. In 1 gram of water, it is 1 by 9 gram of hydrogen. Right? Next, it is given how much gram of water is produced? 0.18. 0.18, it will be 1 by 9 into 0.18, that is 0.02 gram of hydrogen. Okay. Now what will happen? If I want to calculate the number of moles of hydrogen, I will get 0.02 divided by 1, that is 0.02. Okay, number of moles of carbon got, number of moles of hydrogen got. Now I can also calculate the number of moles of oxygen. So for that I need to get the mass of oxygen, right? So you can see in this carbon CHO, I got what? How much carbon is present? 0.12, and how much oxygen is present? 0.02. Right? So let me calculate the mass of oxygen, that is mass of organic compound minus mass of carbon minus mass of hydrogen. What is the mass of organic compound? 0.3. What is the mass of carbon I got? 0.12. Okay, and what is the mass of hydrogen I got? Mass of hydrogen I got is 0.02. So that is 0.3 minus 0.14. Okay, so that is 10 minus 4 is 6, 2 minus 0.16, right? So mass of oxygen is 0.16, and what is the number of moles of oxygen? 0.16 by 16, that is mass of oxygen 0.01. So I have got all the moles. So just let me write down those things first. Okay, just a minute. So I got number of moles of carbon is how much? 0.1. Number of moles of carbon is 0.01. Number of moles of hydrogen is 0.02, and number of moles of oxygen I got is 0.01. Okay. So what is the ratio of this one? 1:2:1. So what is the empirical formula? CH2O. Empirical formula is CH2O. Now what is the empirical formula mass? You have to just add the mass here. So 12 plus 2 plus 16. So that will give me 2 plus 2, 4 plus 6, 10, and then 1, 2, 3, 30. Empirical formula mass is 30. Okay. Now what I have here, just a minute. I got empirical formula mass. Now what is the N factor formula? N factor is molecular formula mass by empirical formula mass, or it is just molecular mass by empirical formula mass. What is the molecular mass of the compound given? 60. Okay, and this one is 30. So N factor is 2. So what is the molecular formula here? Empirical formula into N. So you have to multiply 2 to the empirical formula, CH2O into 2, that is C2H4 O2. Okay, C2H for O2, that is option number B here. Next chapter we have structure of atom. Let's see the number of angular and radial nodes in 3p orbital. So if you remember, we have radial nodes formula. Okay, radial nodes is equal to n minus l minus 1 and angular nodes is equal to l. Okay, now 3p is there, n is equal to 3. Okay, p will be how much? SP 0 1. So I have here 3 minus 1 minus 1, that is 1. So radial nodes are 1, radial node is equal to 1 and angular nodes is SP, right, 1. So I have 1 and 1, that is option number B here. Next, the energy associated with the first orbit of He plus. So you know that energy formula is equal to minus 2.18 into 10 to the power of minus 18 Z square by n square, right? First orbit, that means n value is 1, and what is the value of Z for helium? Hydrogen, helium. So 2 square is 4. So 2.18 into 10 to the power of minus 18 into 4. So that will be equal to 4 8s are 32, 7 and 8. Okay, 8.72 into 10 to the power of minus 18, that is option number B here. The correct set of quantum numbers for the unpaired electron of chlorine atom. So if you see chlorine atom, what's the electronic configuration? Atomic number is 17. So it is 1s2, 2s2, 2p6, 3s2, 3p, I think 3, 6, 7, 8, no sorry, 3s2, 3p6, then I have 6, 6, 12, 13, okay, I exceeded, just a minute. 3p5, right? 6, 7, 8, 9, 10, 11, 12 plus 5, 17. Now if you see 3p5, the last electron, right? So it is 1, 2, 3, 4 and 5. This electron 3p5 is present here. So what is the value of n here? N value will be 3. So n value 3, I have these two options, I can eliminate. What is p value? For p the L value is 1. Right, so I have 3 and 1, so that is this one, option number D. Okay, next, two particles A and B are in motion. If the wavelength associated with particle A, so I have lambda A given to me as 5 into 10 to the power of minus 8. Okay, and the wavelength of particle B having momentum, so I have to find wavelength of particle B. Let the momentum of A is equal to PA and the momentum of PB, if you see, it is half of A, right? We will get this one. Now what I have here, I know lambda or any this one, lambda is equal to H by P, right? So I can write lambda B by lambda A is equal to PA by PB. Okay, now if I have lambda B, what is the value of lambda A here? 5 into 10 to the power of minus 8, that is equal to PA by PB is equal to PA by 2. Okay, so now if I see here, lambda B will be equal to 2 into 5 into 10 to the power of minus 8. Okay, so it will be 10 to the power of minus 7, and that will give me, that is option number C. Okay. Next question number from redox reaction, let us solve some question. So we have to balance this equation. Okay, you can see it is in basic medium, I have OH minus, and you have to find the value of A and Y respectively. Okay, fine, let us do this. So first I have MnO4 minus, okay, that is getting converted to MnO2. Okay, this is plus 7 and this is plus 4. So plus 7 to plus 4, I will have reduction of 3 electrons, then I have 2 water, okay, and then I have 4 H plus. Clear? Next I have S2O3. Okay, so this is like this actually, S2O3 2 minus is getting converted to SO4 2 minus. Okay, so it is, you can see 6, what's the oxidation state here? It is plus 2. and here it is plus 6. So plus 2 to plus 6, it is oxidation, right? So we have here 4 electrons oxidized, and if you see the number of water molecule, I can have here one more water molecule, that is H2O. Now if that I add, I have to add 2H plus to balance it. Up to this it is clear. Now let us add both the reactions, but before adding you have to multiply this equation with 4 and this equation with 3 to balance the number of electrons, right? So if I just multiply directly, I will get 16H plus, okay, I am writing here 16H plus, okay, 4 4s are 16, then I have 4 MnO4 minus, okay, then I have 12 electrons, okay, then this side over, and here I have 3 water, and then I have 3 S2O3 2 minus, and then I have, just a minute, plus 2 to plus 6, right? These 4 electrons will come on that side. It is oxidation, right? Oxidation is loss of electrons, so it has to be 4 electrons on this side, okay. Apart from that, so I have 3 S2O3 and I have 3 water, okay. Just a minute, let me just multiply once again. I think some error I did. Let me multiply once again, okay. So I'm just writing the left hand side now, okay. So if I just write down the left hand side, 4 I am multiplying with H plus, I will get 16H plus, okay. Then I have 4 MnO4 minus, okay. Then I have 12 electrons, okay, and then I have 12 electrons, then here I am multiplying 3 water, okay, and then I have 3 S2O3 2 minus, okay. And now what I can do, I will write the RHS side with a different color, yellow, okay. So here again I will have 4 MnO2, okay, plus 8 water plus 3 SO4 2 minus plus 6H plus, okay. Now if I just want to write the balanced equation, I will have 4 MnO4 minus, okay, plus 3 S2O3 2 minus, okay. Next I have this 12 electrons and I have okay, I have 12 electrons this side, that got cancelled, okay. So I have 4 MnO4 minus, 3 S2O3 2 minus, and I have 16H plus, I have 6H plus, I can take that here, so I will get 10H plus, okay. And after that, so I have written this one, I have written this one, this also I have written, then I have 4 MnO2, okay, 8H2O, this side we have 3H2O, this is 8H2O, so I can subtract here, so I will get 5H2O, okay, and then I have 4 MnO2, then I have 3 SO4 2 minus, okay. So this is my equation. Now you have to think that OH minus is there, right? So to remove OH minus, what I do, we will add 10H plus, I will add 10 OH minus, and this side also I will add 10 OH minus. Now see, when I add 10 OH minus to this one, it becomes 10 water molecule. Now 10 water molecule, 5 water molecule will again get cancelled. So what I will get here, I will get here 5H2O, okay, and this 5H2O will be cancelled here, okay, done. So now let us see the equation A. So we have here, just a minute, let's see the next question, that is question number 90, the oxidation number of nitrogen in NH4NO3, okay. So if you see NH4, okay, NH4 plus, it is actually NH4 plus and NO3 minus. So nitrogen, let it be X, 4 hydrogen, then it is equal to plus 1. So X will be equal to minus 3 here, and if I see here, that is X minus 6 is equal to minus 1, X will be equal to plus 5. So here I have minus 3 and plus 5, that is option number A here. Next we'll move to question that is from general organic chemistry. The first question here is the IUPAC name of the given compound. Very easy, you can just see to start numbering from this side, and the what I can say, the substituent should be named alphabetically ordered. Okay, so I have 3-chloro, 1, so I have 3-chloro, and on the second one 2-iodo, 1, 2, 3, 4, 5, so and 4-oxo, there is a CO group, sorry, there is a CO group here, so 4-oxo pentanoic acid, that is option number D here. Next, which of the following species is an electrophile? Here I have lone pair, so it is a nucleophile, lone pair, nucleophile, lone pair, nucleophile. Now SO3, if you see, it has 6 valence electrons, it forms bond like this, no lone pair, so it can act as an electrophile, so option number D here. Next, IUPAC name of the compound, again here you can start numbering 1, 2, 3, 4, 5, 6 and 7. Okay, so we will have 3 amino, then on the 5th carbon I have hept 5-enoic acid, so that will give me option number D. Okay, 5 questions. Next, coming to question number 94, IUPAC name of this one. So it's a very simple compound. You have double bond, then you have 1 carbon, and you have 1 carbon, and you have 1 carbon here. So you can number it like this. So on 2nd and 3rd carbon I have methyl group, so 2,3-dimethyl but 2-ene, right, 2,3-dimethyl but 2-ene, that is option number A. Next, last 5 questions, which of the following is not a pair of functional isomers? So functional isomers, you can see OH and this one, right, alcohols and ethers, they are functional isomers. And if I see here, this one C2H5O C2H5 and C3H7O CH3, both of them are ethers group. But what is the difference here? These are metamers, they are not functional isomers, so here we will have option number D. Next, coming to hydrocarbons chapter, you have identify A and B. So you have been given with propene, and in the first one I am giving you HBr with peroxide. Okay, so propene is like this, and if you have HBr with peroxide, it will give you anti-Markovnikov's rule, and bromine will be added here, right? So 1 carbon here, bromine will be added, that is your option. This can be there or this will be there, we can eliminate this too. And simply if I add Hi, okay, normal addition of Hi will follow Markovnikov's rule, so you will get I here. Okay, so that will be option number B, option number D here. Okay, next, identify X in the following compound. So you have benzene with 6Cl2, okay, and that will give you, if I have benzene and you are taking 6Cl2, and you can see here that 6HCl is produced, so all the hydrogens here are replaced with benzene. Okay, so you will get here option number A, that is hexachlorobenzene. Okay, next we have identified the following compound which exhibits geometrical isomerism. So for geometrical isomerism, you should have 2 things. Here suppose A and B is there, this A and B should be different, they cannot be same group. Okay, so if I see but 2-ene, they will have same compound. Okay, but 2-ene, if I draw, this is like this, I can draw like this. Okay, so this will have cis, you can see A and B are 2 different compounds. This is cis form, if I draw CH3 here and H there, that will be trans form. So we will have geometrical isomerism in option number A. Next, electrophile that participates in the nitration of benzene. So when we do nitration of benzene, we use the reagent concentrated HNO3 plus concentrated H2SO4, and these 2 reagents together provides us the electrophile NO2 plus, that is option number B. Next, last question, the compound that reacts fastest with sodium methoxide. Okay, now sodium methoxide is like this. Okay, it will, so if I have any Rx, it will attack in this way. So this is basically a nucleophile and it is attacking on an electrophile. So the one where the electrophile will be better, with a compound which is a better electrophile, will react faster. And how we can find electrophile? If I have electron withdrawing groups. So if I see the options here, We have two electron withdrawing groups, so definitely this is most electrophilic. Here I have only one electron withdrawing group, here no electron withdrawing group. Here the electron withdrawing group is present at meta position, but also one is present. Here two electron withdrawing groups is present, so it will be more electrophilic, so that is why it will react fastest, so that is why option number A. Okay. So students, that's all. We have solved top 100 questions. So if you practice these 100 questions, similar questions will definitely be asked in the exam, and you can easily score 40 plus. Okay, you can score more than that, but I'm telling the minimum one, right? So please do practice these questions. Just practice the formulas that we have discussed again and again, and if you have time, do similar questions more. Okay, all the very best and study hard.